All right. Hopefully the music's not coming through the mic too much. Let's see here. What else do I need to do? Oh, I need to pop out Twitch chat. Twitch chat is just contained within Twitch right now. Twitch TV to Obotter. Go to that. Go to Obotter. Mute the audio. It's muted. And then I need to pop out the Obotter chat. But I pop it out on Twitch again. Little gear icon, right? Yeah, pop out chat. There we go. All right. Then I go over here to my social stream and I hit refresh. And everything should be worked out. Just do a quick test. And then nothing works. Of course nothing. Of course it doesn't work. Yeah, that's definitely the way it should be. Totally not working. That one's there. And then I should have YouTube there. I'm gonna test on YouTube because it's my full name. Okay, so there's Lawn Dog. And it's not showing up on my... Why isn't it showing up? It should show up here. It's not. Hit refresh again. I right click and... No, nothing about the user. Don't do that. No, none of that's worrisome. No audio on that. I need to hit reload on this, or can I don't know what the clear messages command is here. Nothing. Yeah, thank you for that. Well, it works up there, so that one's working. I don't know why this one isn't working. Let me just close the tab and open it up again. Nothing. Why is that? Another one. Why is it like this? Why do you have to be like this? Did I open it up on the wrong Twitch TV pop out, Obotter chat pop out, and there's another YouTube message. And it's not coming through all the way. But it does show up there. That one works. This one doesn't. The one that I use to read chat doesn't work. It has something to do with the Nightbot messages. How do I clear the chat in social stream? That's just Chrome. Let's see. Alarm bells, emotes, auto, I don't know what that is. Sweep. Doesn't do anything. Useless. Useless. Hit refresh on it. Maybe that will work. Nothing. All right, I guess I just got to use the right hand monitor to read you guys today. Is that the goat? Go to Modi. Delivered a new set of computer speakers. All right. New speakers are fun. God, I've lost control of this project. We'll get there, though. We'll get there. Basically, we got to make like a little board that's going to go in this thing, and it'll be a high side current monitor that uses an op amp, and maybe the OPA 3-volt op amp. We're going to do a little reverse engineering of this thing so that we can figure out what the heck's going on. Let me get one of the boards out while we're there. While I'm on that subtopic. I got Rob Haas to react to a Corgi picture today. He was in the middle of playing Dwarf Fortress, and I posted to his little hideout a picture of Willow because it was a particularly cute one. I put it on my Discord as well now, but it got him. He was like fucking he said it's not what he wants to see right now. It's like fucking dog. It's too cute. That's an appropriate reaction. Jesus, that thing hopped out at me. I didn't even get that on camera. Damn it. Got to get those moments on camera. God, I have to clean up. It's Friday. Friday's typically the day you neaten everything up when you don't have much other work to do. But we got too much other work to do. We're supposed to be programming a cool little screen, but we haven't even gotten around to that. I need to do some work on these things. I want 3 functional displays on the front of this thing so that I can see what the power supply is doing. So I know whether or not I'm blowing up, like if I'm arc welding a module or not. That's actually a really important feature. And I don't want it to involve more microcontrollers. I could always have a microcontroller in there and have its own little screen that would then display what the statuses of the currents are. But I don't want that. I don't want to do that. Instead, I would rather have little individual modules, and I guess these have microcontrollers on them anyway. But what we need to do is we need to make it a high side current monitor, not a low side current monitor, because for some fucking reason, everything in this device decides to share ground. Ground, even though it is going to be at 6 volts technically compared to the negative 12, you know, if you think of it in terms of DC, the whole number line shifts. You got to be able to do that in your head. So it starts at 0, goes up to 6 volts, or sorry, 12 volts, and then it goes up to 24 volts because it's plus minus 12. But yeah. I don't remember anything. I don't have long-term memory. That's not something that I have. That's what happened with my buddy's subwoofer. Is he had a really nice like home theater subwoofer, and it just stopped working because apparently Klipsch just can't build subwoofers. They can do great speakers, not good subwoofers. And so he was like, "Here, have it." I'm like, "Okay, cool." And so I started poking around at it. It took a little while to figure out what was going on. Apparently, there are some gurus out there who do nothing but fix Klipsch subwoofers, so they know like what all the stuff does, but they don't have experience with the super duper one that I had. But what really helped is that the design of all of these is just about the same. This one just had some extra features and it was built better. So got all the Silastic off of it, looked around. Nothing was really wrong with it. There was a burnt out component. Something exploded. Like not exploded, but just like heated up too much and burnt out. It was still working though. I replaced it. Didn't fix the subwoofer. It was still intermittently working. Turns out the mechanism that turns on and off the subwoofer on auto mode it's this little standoff board. Those little standoff boards get vibrated with everything. So they try to lock them down with Silastic. Tested all over the board. Test point, test point, test point. Nothing seemed to be wrong with it. And just on a whim, I decided to just test a random old trace, and there was no continuity. But I could see there was just a big resistor there. What is there's like talking in this song, and it's really distracting. Anyway, the trace had a resistor sitting on it, and I got no ohms across the resistor unless I tested directly on the resistor. So there was a broken trace. So scrape up a little trace, hit it with some solder, perfect subwoofer from then on. So now I've got a giant theater subwoofer. This song is really, I wish I could skip it. I wish I could skip it. It's really fucking me up. I'm hearing voices in my head. YouTube can't hear the song. It's only on Twitch. But it's one of these like, this is a chill mix from Decker to the Space Cowboys. And this song is just like kind of a chill beat. Right? And then suddenly there's like 7 whisper talking voices with like an echo filter on them. And it's like get out of my head, Charles. Oh my God. Now it decides not to do it, so I think it's just messing with me. There it is again. This song cannot end sooner. Why is that one trace? It's like blanked out. We don't have any identification on this thing. This is one of those meandering songs that really pisses me off. Like, it would sound really good, it's just that whoever made the song decided to put a bunch of bullshit on one of the layers of the song. So it's like this good song, but then there's the sound of like somebody doing the dishes in the song, and they decided to do that just to get some audio fill in their deep house track. They're like, yeah, I recorded somebody like just farting into their microphone and I put an echo on it. Van Halen. What? It's nothing related to that. I'm just talking about this song. So there's one row for the display. Let's see. A couple capacitors, a couple resistors, 10k ohm, 4.7k. 3 is that 30k? No, 300k. Wow, that's a big one. To ground, 300k to ground. So filtering. What's going on this one? Is that one just connected to ground? I think it might be. We're basically bypassing all of this jazz right here and going directly into the microcontroller. Wow. I should have shown that on camera. That would have been hard to see. I had a component lead because my wrist was sitting on the fuck. God damn it. This is what I was saying in the Discord. These fucking things will stab you dead. You gotta watch out for these component leads that sit on the desk after you clip them. I've drawn blood just by moving my finger near one. Jesus Christ. I didn't expect that to happen. I was just moving my finger and I accidentally fucking perforated myself. But when I lifted my wrist off of the desk, this thing was sitting at a right angle to this part of my wrist right here. You gotta watch out for these little leads that get cut and brushed off onto the desk. Because they'll have an extremely sharp end because of the way that the cutters cut them. God, that hurt. I don't have to do test strips anymore. Only in an emergency. The constant glucose monitor has a mechanism by which it self-calibrates, and so I don't need to calibrate it with a finger stick. Don't need to do them anymore. Ow, that's gonna hurt. That feels like, because that's up under the nail almost. Damn, that's where all the nerves are. God, all the nerves that I haven't ruined with 20 years of finger sticks. Dope. Bump. Get this stuff out of the way. Maybe we should clean up a little bit while I'm sitting here. I don't even know how to start to approach cleaning up this mess. Holy shit. I can't do it. Look at this. Oh man. But I'm gonna need this stuff later. We're gonna have to get it to the point where I guess we test this thing with a couple different currents to see how it reacts, and then we have to figure out what current mirror circuit we're going to use and what values we're going to use in that circuit. And I'll make a little surface mount board that's going to hang out on this thing and take its cues from the whatever this thing does. How's it going, Mahalo? Well, place for everything in its place. You got to have spots for things to live. We can tear into this a little bit while we're waiting. Put all the components that are going to go into the power supply over here. I don't think the 3-volt thing is going to go there, but I'll hold on to it anyway. Move this out of the way for the time being. For fealty to the being made entirely out of time. I am the time being. Stare into my buttocks. Let's do another board for the control board with all the components that I'm going to need for that, including the level shifter, inputs, outputs, whatever else. Breadboard stuff I got to stick back onto the breadboard. Connectors that have no business here for some reason. Well, that's a 5-pin. That's more for a module than it is for a power supply, so that goes over there. I really wish my social stream blade would freaking work. How do I clear this? I don't understand. If like Chrome is pulling from a cache every time. I keep opening a new window for it and it's not coming up blank. It comes up with, yeah, it comes up with the whole chat ledger. If I could clear the cache of this website. Find and edit, more tools, help setting, blah, blah, blah. Turned off 2 unsafe extensions. Which are those? These extensions may soon be no longer supported. Okay. Whatever. Okay, well, that's not going to do it. That's not helping me. Oh, did I? No, never mind. Everything still sucks. Weird. And then these don't work either. These overlays in the windows. Refresh the cache on that one. Maybe that'll pop up again. Something's going on with my multi-chat extensions here. And it could be that Chrome support thing where they're not supporting certain stuff anymore because they're a bunch of dickheads. Bunch of dickheads. Oh, wait, a lot of them. No, that's not it. That's not it. I can't do accents. I try. I can do accents when I'm alone. And they're perfect. Because I don't have selective hearing. So much mess. Mess. Gotta handle this a little bit. I gotta dial it back so that I have some room to think. A messy desk is a messy mind, and as such, I need a blank desk. I need an empty desk. These boards do not fit in this bin anymore. Organize yourself, organize yourself, organize yourself, organize yourself, organize yourself, organize yourself. It's not really working. I mean, I guess I got it to close, but shouting at it usually works. That's usually what works. Cleaning. I'm cleaning. I'm cleaning! Arrgh! Oh yeah, the power supply board should probably also have my voltage references on it, which are these two. Although they're not going to actually get these, I'll build the circuit somewhere else. Although it would be kind of good if I did everything on standoffs. Every single circuit in this thing would be on a standoff, and then it would be removable and testable, separate from the device itself. That's kind of what you see in like research projects a lot. This is actually a pretty good deep house mix. I don't know why he calls it a chill album. It doesn't really need to be called a chill album. It's just good deep house. Kind of stuff I like. Kind of stuff you can dance to. You can really move to this. You could really bust a move to this. We saw Juno Reactor way back in the day, and I have never danced so hard to a show in my life. He shows up with a pink shirt and some fellas from Africa who spoke in click tongue, and they did like a little thing on stage. It was great, but I don't remember ever dancing that hard to music before. That was before techno was cool. I used to get ridiculed for listening to this stuff, and now everybody's into it. It's like anime. All kids are into it now. Although our techno was significantly different from this. Ours was a little bit worse. It was not that great. Switch over there. This is a switch I just took apart just to show people how a switch works. These might go back in, these two big capacitors. I'm going to put them on top of that, because that thing has a high-pass filter built in, so there's no... DC doesn't get into it. Garbage, garbage, garbage. A screw that I'll never be able to find out what it was supposed to go for. I have piles and piles of these little screws, and they just end up back in a generic screw bin. These go to the garbage. Hold on, I gotta get up to go to the garbage. Gotta clean. Must clean. Clean, clean, clean. We have a clean Friday, so I can work. Because I gotta get this done, because this is like the step 4Z of this this is such a side project that shouldn't garner this much attention. These current monitors were supposed to be a set and forget, like, okay, I'm just gonna buy my way out of this problem. And what it did is it created a new problem, a new fascinating problem, which is a problem in and of itself, because it's too tempting to not work on. It's such a great deal that I can't afford not to buy it. That's what this is. That's what we're dealing with right now. Which is not something that I should buy. Right? It's like, what am I doing? Finding circuit boards everywhere. Here's, these guys need to stay together. Those go here. Port expander, I'm probably going to use new ones, not this one. This one is very annoying to get into the prototyping board because it kind of sits low and it's hard to get out of there. But I guess I'll put it with these just for new. Power cable, don't really need it. It's all in this back deck here. All this stuff that just kind of got shoved out and then over. That just needs to get kind of neatened away. Oh, is he gonna do a goofy song now? This is supposed to be a chill mix. I was told this was a chill mix. Oh, this is how I'm interfacing with the screen. I want to keep this one together. I don't know where I'm gonna put it though. Put it right there for now. That's how all these piles start. All the piles start as I'm gonna put this over here for now, just until I need it. This is shaping up, could be a cool song. All right, not the beat that I would expect from this song. Is this coming from the previous one? I think it is. Oh my God, what are all these cables? What's going on? What is happening? Adjustment goes with the scope stuff. All the scope accessories, by the way, if you ever get like a nice scope. Oh, restart and install the latest window update. Okay, yeah, this is a great time. I'm not doing anything right now, Windows. This is a great time. There's no way that I'm like recording a stream right now and I'm trying to be a little bit goofy for chat while I clean up. No, that's a totally acceptable time to restart the computer that I'm broadcasting with. Snooze. I never want to listen to you again, Windows Update. You always bring strife and pain. Your computer might be vulnerable. Listen, I don't give a shit. I just don't care anymore. My computer might be vulnerable, but my identity has been doxed several thousand times by websites that I was pretty sure kept their records safe. You know, they have enough money that they should not have a giant hacked dump of everyone's social security number on the platform. But they do that almost constantly now. So my apologies if I do not take your Windows threat due to not updating very seriously. What they would find on my hard drive pales in comparison to what has been doxed by, like, MoviePhone. Oh, there's my credit card number on the internet again. Oh, but don't worry, they got into my files and got to my... What? What exactly? They got into my, that picture that I'm saving to share... The cute picture of a dog that I'm saving to share with somebody. They got into my Photoshop. Like, what a disaster. Oh, my storage cloud got hacked and they got into all my credit card numbers again. But they also got into my desktop where I have a copy of my to-do list in a notepad file. There's so much crap on this desk. Holy shit. Oh, there's a 3904. We're looking for a 3904. Here's one. I'll put that over here. This is a I2C ADC, which I guess we don't need. Oh my god, so many of these things. Let's get these into the bin. Into the wire bin. We've been doing low-level projects so much that the mess has accumulated, and it's time to kind of rein it in a little bit so that I can regain a little bit of preserve some computation cycles in my brain, basically. I don't have to be thinking about how much of a sty this is. Bum, 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 bum. Get all the useful stuff out of this pile so I can just sweep it off and throw it out. Throw it out. Out it goes with the garbage. There it goes. These go with the twisty ties. I usually save twisty ties. I save them in a big bundle because when you have like a bunch of wires to keep together. Oh wait, no, I wanted to save these. Let's just go there. Okay. Hardware, hardware, hardware. We've been doing hardware. How can you tell? Transistors. Got dog hair in them. Power supply stuff. More of these guys. I don't know why there's so many out. That over there. Get this stuff out and away. That doesn't have anything on it. That's weird. Okay, now, the short jumps for the breadboard stuff need to be preserved. What's up, Beat Drop guy? At this point, it's a bank insurance problem. End users are pretty powerless. Yeah, it's like all these doxes. But what I mean, I just mean that all of these doxes pale in comparison to like all of the safety stuff that Windows tries to sell you on, as if there are like hackers like banging at the door constantly, right? My computer is under so much risk that Bill Gates has to get his spindly fucking finger into my computer and restart it in the middle of a stream, right? I'm so vulnerable, so vulnerable. My computer is just like a baby in a blizzard, right? It's just ready for exploitation. It's gonna be fucking torn asunder. They're gonna bifurcate my entire online presence because my computer didn't update in the middle of what I'm doing, because all of these low priority things constantly, these stupid little Windows updates. Oh, this one has a particular you know, fix that it has to do, and it also has to turn on Copilot, which nobody asked for. And like, what am I protecting myself against? Oh no, they got into my desktop PC where I keep nothing. I keep nothing on the desktop PC because they convinced me to use all of these cloud storage things under the guise of safety, and then all those things had mega leaks. Mega account leaks. So like, what are we doing anymore? Who do I try? Do I really need to restart my computer to update Windows? No, I don't think I do. I don't think I do. Oh, I'm gonna get hacked. Good. Maybe they'll clean up my desktop a little bit. Thing's a fucking sty. I'm just so done and tired of all of this computer security shit. But that's what they want, brother. Well, fine. They win. You win. You win. I'm writing shit down on a piece of paper again. I'm just gonna write it down on a piece of paper. But that's super insecure. Yeah, okay. Oh man. Okay, so I need the small links here because those are the ones that I use the most. All the other ones I'm just going to sweep up and throw out because I can't be bothered. I need tweezers to do this. My grubby fingers are too wide and manly. Oh, they're right here. They're right in front of me. I hope this one isn't one of those 10-volt regulators, because those are expensive. For a part that's this big, they're like $1 each. They're not cheap. What the hell? What was that? See, just the act of me putting my arm down on this table is enough for me to accidentally sweep things off onto the floor. So I need it a little cleaner. All this is going in the garbage. I can't think about it anymore. Yeah, this is a good mix. I like this mix. Although I do wish the the tech house songs would be a little bit more tech house and a little less random noises over tech house. This beam stuff needs to go in a separate area. And then I'll get the big breadboard out of here because we're not dealing with it right now. That'll free up all of our space. Let's put those right there. Like, there's still derelict wires God, I can't stand it. I'm such a slob. This is killing me. Get your shit together. So my supermarket was playing Ayaya music. Dance party in chat. It's a good mix. They were playing Ayaya music. It was some like it sounded more like regular, like normal music, but it was Ayaya lyrics. It was singing about like kawaii and stuff like that, and I'm like in Acme, like I'm looking at Ham, like I can't deal with this. What is this? I guess that stuff has gone more mainstream than I thought. I can't even begin to identify the song. All I remember is that it was akin to normal music, but there were Ayaya lyrics to it. There was a lot of, like, things were being said in Japanese that I did not understand. Nor care to. Like, when did that happen? Like, Acme's were like, old ladies go shopping. Why is this music here? What is this? Is this a joke? Am I a joke to you? I'm just using these extra ties that I found to just put them around the power supply wires. Though really, to be honest, they should be, well, what I really should be using are the banana to banana, and then I can put the bananas in the ports of that breadboard. That would be a good way to do it, but we're not stressing that. There's so many just little pieces of wire, and they're probably double the amount under me right now. These things are like little syringes. As I displayed earlier by freaking drawing blood on one by accident, by trying to point to stuff and not knowing where my handle is. Look where my handle is. So something overloaded my social stream blade, which is what is supposed to be my finger on the pulse of chat. I'm supposed to be able to see what messages are coming by on that window. Luckily, my numbers are way down and nobody watches my stream anymore, so there's like 4 people in chat, overall chatting. And I think they're the same person on just 4 different computers. But it's not that hard for me to keep up with. It's just right now, for some reason, the screen that I look at isn't updating, and I don't know what the deal is with it. On OBS, I can refresh the browsers, and I don't know if it's something that Chrome is like, because of all the Chrome update rollout stuff that they're doing lately in order to become more of a shitty company and piss off their users. While shoving ads down our gullets that we don't want. Force feed me ads. Do it. More ads, more advertisements. You know what attracted me to Twitch originally was the fact that the users would be the streamers would be supported by the users. And for the most part, that seemed to have been the case. And then all the back end Twitch would handle. But then Twitch went, look at all this money. And they decided to then slowly creep ads into the service, which is what everyone is doing these days. And I know people call it enshittification. And I suppose that's what it is, but it's more like the only natural evolution of these companies for some reason. It would have been nice if somebody could have just thrown a middle finger up at these executives and just said, you know what, no, we're going to keep this pure. 3 streams in a row, audience is fried. Well, that may be true. Yeah, I could split them up next time I do that, but I had to make it up to you guys. Some people on this platform stream every day, and it's crazy that they're able to keep that up. But yeah, we're on day 3 of the marathon stream because I did the Wednesday to make up for not doing Tuesday, because I've been kind of wishy-washy with the Tuesdays just because of life. Things have been happening in life that have affected my schedule. But yeah, I'm making it up to you guys, and I want to get some stuff done on this project. It seems as though we've sort of gone down a branch to like a smaller branch, and then like a twig, and then a vein, and then a capillary. We're down so many branches that we're in the fucking soil at this point. Like, I don't know why every facet of this project has to be so frustrating, but it is. Insane. I just want to find like a little box that does high side current monitoring. Doesn't exist. There are things that I can use, but they're not what I wanted. I wanted volts and amps just on a nice little, smart little display. And while these are ubiquitous, you can find them everywhere, they're all low side. We're shaving a tree instead of a yak. We're doing something. Something's happening here, and I don't know why every turn of the... We're down here with the dinosaur bones, though. It doesn't get much simpler than this. So we're gonna get into this. All right, actually, I want to listen to the song now. This is actually a good song. No, I probably shouldn't do that because YouTube doesn't hear this. It's the same person but 4 different personalities. Ah, there we go. Yeah. Watch channels like yours to see how you guys organize your parts and things for this hobby. Gives me an idea of what works. This is like my storage is just, it's not unified in any way whatsoever. It's like a bunch of disparate ideas that I had for organizing, and they all go 30% of the way. There's, you know, like microcontroller and breadboarding modules. Over here, I've got a couple sewing bins. These are from Michaels. They're just sewing bins. And I've got a whole stash of them over there that have sort of individual projects in them. These have like supplies, like wires, breadboards, headers, all have their own little sewing bin that's within reach. Up here, I've got all my wrenches and stuff. And then there's a big spool of all the wire that I use to build circuits with. Then screwdrivers are on a magnet hanger in front of me. Over there, I've got the tool bin, which is filled with tools that I occasionally use, not the ones that I always use. And then there's a chest of drawers that has all the big tools that I occasionally use. Beyond that, there's bin storage of various components and stuff. But it's like there's components in there, there's stuff down there, in these. I rarely get into those. Those books are filled with surface mount components. There's a joystick I took apart. That's a bunch of motor stuff from RC Cars. That bin is full of... What is in that bin? I don't know. One of these is Nixies and other components. There's vacuum tubes like over in that corner. And there's like some extra header bins and some extra PCB bins in there. And some other project stuff. It's a mess. It's not organized. There's just so much. I have a strainer. I have a strainer right there. It's on my shelf, just in case I need to strain something. Do you need to strain something? I don't need to strain anything, but it's there. What's up, Tequin Dragon? Good morning from New Zealand. Hey, how you doing? Good to have you here. I'm having a mental breakdown. It's day 3 of my marathon streaming, and I've lost my mind. Just because of all of the fractal yak shaving that we've done. Fractal project. It's sort of, if we look at, oh, there's a little branch here. Let's take a look at that. Zoom in on it. Oh, look, it's a whole nother project in and of itself. That's how it's been. That's how it's been. I'm sweating today, though. It's actually really nice out. I should be touching grass. But I'm in here, building circuits. All right, let's get started. Let me get the music out of here. The Twitch can hear the music, but YouTube cannot. YouTube cannot. You cannot hear the music. Now nobody can hear the music. Let's get started soon out of here. How's it going, everybody? Listen, so we've been working on a module testing module. And like everything, this module testing module is a side project to a primary project that is also a side project to a primary project that is also a side project. It's turtles all the way down and up at this point. We are putting together a circuit that will measure what's called the high side current of a power supply. So the power supply has a positive and a negative, let's say. In our case, we have a positive, a ground, and a negative. And that's kind of a problem because every single current monitor that we can find is a low side current monitor. Now, the low side current monitor relies on you isolating the ground out of whatever you're monitoring. So you have positive and negative. Negative is where all the electrons sit, but the positive has the potentials. And so the high potential, the high voltage, you don't have to deal with if you're doing a low side current monitor. You put a beefy but very accurate and very low value resistor in line with that ground, with the ground the isolated ground, and you can measure the volume of electrons that are flowing back through by the voltage drop across the resistor. That's a fairly common thing. It's fairly simple. You can also do the same on the high side, but apparently all of the current monitors that I can buy are low side. And because of the topology, because of the design of the Eurorack modules, we have a shared ground. And that's generally what you do, is you share the ground. Everybody has the same ground potential. Easy thing to do. What that does is that shrouds your electronics and electrons. It allows things to be less noisy. It gives a return path on things like static electricity. You have all kinds of advantages for absolutely fucking pasting your circuits with ground. You shield everything with ground, right? That's all well and good. You know, that's great. You have grounds all over the place. It's common practice. All of these current monitors that I can find, at least the cheap ones that I can buy, are all low side current monitors. And I guess they're for higher voltage systems, so that if you have like a bank of rechargeable batteries, you can monitor that with just a little doobly thing that you just like put on a panel and you go, ah, there's the voltage and current. But that's not what we want. We want comprehensive monitoring of our plus, minus, and other voltages, and they all share grounds. I can't isolate them because at the module itself, all those grounds are just connected to one another. So it's not this. I can't really do that individually. This is the issue you closed out yesterday with. Yes, because of the whatever's available. Because of whatever's available, I can't find a dedicated high side current monitor that fits what I'm looking for, like cheap little panel mount thing that has volts and amps on it. So in order to not draw this out and to not totally change the technology, I have looked into basic circuits. Oh my God, basic circuits. And what you can do with an op amp is you can make a current mirror circuit. What that is you basically use an op amp, which is fairly more robust. You can use an op amp to do the comparison of voltages across your resistor and use the millivolt difference that the op amp's going to output and put that over to an ADC. And so I think what we'll be able to do is take the circuitry that is monitoring a voltage level, because you don't really have current monitoring in microcontrollers, right? You typically look for like a voltage level, or sometimes more advanced ones have like a differential engine in it, but I don't think this one does. Even if it does, what we want to do is we want to take a look at what the output of the shunt circuit is and mimic that with our own high side monitoring circuit. So we will remove all of the stuff that makes this microcontroller sense current, and we will replace it with our own tuned circuit that will make it sense high side current. Easy, right? No, but we can do a little circuit surgery and a little bit of reverse engineering to get there. Why are we doing this? Because I've lost control of the narrative. That's what it is. I've lost control. I said, Jesus, take the wheel. And Jesus said, I don't exist. And we barreled off of a cliff. And now I'm trying to survive in the desert with a broken car. Yeah, I've totally lost it. All right, so, boop. So what we have is the current monitoring device. I've got two of them in here. I've taken one apart, and I got the PCB for one. Is that what fell off the desk? Where'd it go? I lost it. I lost my marbles. I lost my marbles, chat. Where did it go? I think it fell. Is it down on the floor? I'm looking around. I'm looking around for it. Or did I not see it when I swept? Hold on. Where is it? Where are you hiding? Oh yeah, it's right here. Okay. This sentence is false. I only tell lies and he only speaks the truth. Okay, yeah, this goes in the pencil bin. So this little circuit is not that complicated. So let's take a look at it and see what makes it tick. Yeah, see, there's chat. I don't know why my chat isn't updating. It's just not working. My blade is just terrible. This should be showing me chat, and it just doesn't. And I think it has to do with these commands. Yeah, I think this might have lost some permissions. How do I give this extension all the permissions that it needs? Hold on. Get this into a big window and look at this. Connection is secure. Cookies, data site settings, about this page. Social Stream Ninja. Yeah, it says everything's fine. Which is great, because everything's not fine, because this doesn't work. Maybe if I close this and I use the Stream Deck to open up the pages again, because the Twitch chat is... I've refreshed the window about 100 times now. Yeah. Set up web pages, and now it's going to open a couple pages here. Oh my god, it's so many web pages. It opens like 6 web pages to get everything working. We be cool and frozen. You guys are frosty. Although you were in a dark window on the moderator one. Now we're in a light window. Maybe that's what'll do it. And then this one gets closed. I don't know what camera I'm on because everything's getting covered over. No, it's just not updating. It's like persistently not updating the Streamblade. That's so weird. I don't know why it's doing that, or how to like get the specific page's cache deleted. Because these are all messages from yesterday that it's got just like in its gullet. And at some point, I guess Chrome might have frozen out the permissions for it. Relaunch to update extensions. Oh no, that's not right. Browsing data. Find and edit more tools. Huh. Holding shift while... I always forget about that trick. That didn't do it. God damn it. Do it again and again and again. That's not going to help me. That's so weird. Yeah, I don't know. Something did it. Deleting all cookies. I don't want to do that. Then I got to sign into everything again. That would probably fix it, though. It has something to do with these Nightbot commands. Like when these come in, it stops scrolling. I don't know if maybe something stopped it from scrolling. That's send message. That's emoji. Clear the featured message, not this chat. No. Auto feature the messages. That's not something that I ever want it to do. Scroll to bottom. We're already there. Pause. Play. Nah. I don't know. I don't know how to fix that. That's weird. All right. Anyway, so what we need is a circuit that's going to produce a voltage depending on how much current is there, and that would be called a current mirror. So current mirrors we know all about. We were looking at them yesterday. We built this circuit. Thing is, we just don't know. Wonder if Nightbot is breaking HTML. Can you turn it off? I don't turn off HTML. Turn off Nightbot. Full access given to Social Stream Ninja. Session channel ID? What is that all about? Well, I'm closing that. I'm not doing anything with that. I don't know. It's on. The version is, I think, the latest. Inspect views, background page. What is that all about? Permissions. Access page debugger, read and change all the data on the website. Site settings. I have it asking for permissions if it needs it. Extension options. Oh, that's just that. Settings related to the social stream extension. Session channel ID and permission. No, I'm not doing that. Pin to toolbar and allow an incognito. None of this stuff. Can we do like a cache refresh? Doesn't seem like it. I hate Chrome lately. I really should be going over to Firefox. Do those things in that order? Yeah, it's just borked. It may come back. I don't know. Sometimes it fixes itself. A full computer restart is probably due. That's probably the whole thing. Just restart the whole computer and it'll probably come back to working. The ones that are in OBS, like the web pages that OBS is opening, those work. That's why this is coming up at the top. So something is still working about the plugin, but for some reason mine specifically just decided to shit the bed, so to speak. Okay, anyway, so what we're trying to do is get a voltage out of here. Now, I don't know what voltages are coming out of the other circuit, so we need to put a little bit of time into reverse engineering the other circuit so that we can put ours in. Let me actually, before I do that, I want to get this out of here because this will continue to confuse me because this is a slightly different circuit setup than what we will have. So deleting that, and then what we're going to do is we are going to build a circuit that looks like this. No, not that. No. Image. There we go. Oh my God. Didn't work at all. Use the snip tool. You know, what they need to do is just roll the snip tool into MS Paint. That would be much nicer. Instead, they have this weird sort of engine in here where you can, like, write on stuff. Strange. Not to get sidetracked. I'm not reading your comment. Jeez. That is transparent. Not to be rude, but I am working right now. I'll come back to you in just a second. Okay, so we need to do this, whatever voltage level this screen uses, we need to get that to there. Because instead, this will go directly to the microcontroller. This whole circuit will just go directly on the thing. Read the comment. God damn it. Put it to sleep or hibernate. I don't know. I don't know. You'll have to look on somewhere else to find an answer to that, because I don't know. All right, where's the YouTube? YouTube comments have like fallen behind everything else. Let me move this over here, bring that up. Have that nearby, and maybe cover over Dinsdale Piranha, because I just don't want to hear from that guy right now. What the hell is your problem, Dinsdale? Actually, no problem with him right now. It's totally fine. Okay, so back over to here. So we want to use this circuit in order to get a voltage out of the thing. Now, the thing about this is that 0 to 4.3 volts might blow up our microcontroller. So we need to figure out what voltage corresponds to what current. Do you want a list of what the hell is your problem? Everybody needs to carry one of those around. So if I go, what the hell is your problem? They're like, you know, piece of paper, here you go. I'm like, oh, okay. Yeah, no, that makes sense. Okay, because we're not necessarily in 5 volts. We might be in 1.8 volts, or we might be in 3 volts. We need to figure that out. And in order to figure that out, the first thing that you reverse engineering something is the power supply. So we need to look at the power supply that powers all of the device. So we look into that, right? Simple, right here, right here. See that? That's what we're looking at. That right there. Do you see that? That's what we need to look at. That's the power supply. I think. Well, let's see where power comes into this board. I keep the lists on a flash drive for convenient storage. Oh yeah, that's what I want, is some random ass person on the street handing me a flash drive. Let's get the display out of here, and then we can see where these circuit traces are going. And then we'll put the display back in and get it running and, you know, figure out what we're feeding in. Because it looks like we have 3 pins here that are doing something. It's not going to be too difficult to reverse engineer. But it'll be way easier if we can see the traces. A little handheld printer. Yeah, that sounds like such a weird thing to have. You imagine somebody just whipping out a freaking paper printer? You're like, I don't even I'm not carrying paper with me, and yet here you are with an entire printer. That'd be a great way to give somebody your card. My card? Oh yeah, one sec. Mirror, 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 mirror. Oh, sorry, it's smudged. Let me print you up another one. That's what, what's her name? The sexy cyborg? She put a 3D printer in a backpack and walked around with it. And since the printer is all indexed on itself, and the mechanics are pretty good, and the motors are generally like kind of locked when they're not in motion, unless it's powered off, it did a good job. It actually printed something out perfectly fine while being in a backpack. That's already a thing. Yeah, they were already working on that. And if they're not, you know, there's somewhere in the government they're probably looking at some kind of an AI that does this. I mean, look, AI and electronics have existed in tandem since the early 2000s and before. They were talking about having AI make the decisions of where to run traces. So that's been a thing for a long time. Japanese solder sucker is magical. Yeah, it's really good. And these holes are way too big for the pins, so that helps us out massively. I want to talk about AI. You brought up AI. I want to talk about it. So I shared a picture of Willow on Robert's like hideout, Rob Oz's hideout, and I got him. I got him in the middle of the stream. He was playing Dwarf Fortress. And was like, fucking oh bother and his cute corgi. I got a good laugh out of that. This is almost out. This is actually wiggling around. Oh, let me personally bring you up to speed. This is one of those low side current monitors, and I just explained that we're turning it into a high side current monitor. And in order to do so, we need to do a little reverse engineering. Are you good now? Can I get to work? I did this to myself by paying attention to you guys. I give you guys too much attention. No work, only explain. I know that. Hey, some days are like that though, where it takes me like 20 minutes to go through the explanation of what I'm working on because it's so stupid and complex, and I've fallen off the deep end in terms of the project narrative. I've lost my way. And then in like the next instant, I get people going, bother, why don't you ever fucking finish a project? And I'm like, how dare you speak to me? Brighten this up a little bit. Well, actually, I need to get the other light in. But first, I need to get this little bead of solder off of this pin. There we go. Hopefully not too much damage to the things here. Now, this should give up the ghost pretty easily. That's always nice when that happens. Man, they really left the cool part on the back of these things, the smoky epoxy set. All right, let's put this thing over here. Now we've got full traces, sort of, except for the things that are blocked. This is like working in an open office, always somebody talking. Oh man, that's when I bust out the headphones. But whenever you bust out the headphones, your boss always wants to speak to you every 2 seconds. And so they come up to your desk and they stand by your desk and they go, why aren't you paying attention to me when I want you to? And it's like, fuck's sake, I'm trying to get work done. Like, quietly. And then they go, why don't you get it? You're not getting enough work done. It's like, go away. No, my earplugs were headphones. I had the Shure EC7s, which are still about the same price as they were back in the day. They were like $70 earbuds, right? Which was absurd back when I was in the office. But nowadays, it's like nothing. But they're amazing. The EC7s have to be my favorite earbuds of ever. And they have those, either the rubber plugs or the foam that you can squish and it'll unsquish to your ear. So they are basically earplugs. Oh, such beautiful isolation. Yeah, so Full Moon, I don't know if you know, somebody sent me this solder sucker, the EC or Engineer like SSO1, I believe, and the Engineer is in the Star Trek The Next Generation font. That's the good one. This thing is awesome. I've refurbished this thing a couple times. You can fully take this thing apart. So you could act like you're some assassin. You're like, yes, I got to put together my tools. But what I did is I used dielectric grease because I happen to have a giant tube of dielectric grease. I use dielectric grease in it, so as long as it gets some kind of grease, it functions like it's new. Up here, you have a little piece of silicon rubber hose, which does not melt in contact with the soldering iron. That's really important. You know, those other solder suckers, those plastic piece of shit ones, are awful because you melt the tip when you use it, and it's just terrible. I hate them so much. This is great. The piece of silicon rubber can create a gasket around what you're sucking and create actual suction. So it works a charm on everything, and then you can fully refurbish it. To get another piece of this little silicon rubber, it's very rare that this company actually puts up new stock of their silicon rubber hoses. Don't be fooled. It's just silicon rubber hose. It's 1/4 inch silicon rubber hose, or what is it? 4 millimeter inner diameter. I think it's 4 outer and 3 inner, maybe. But you can find it on Amazon very easily, and you can get the really clear stuff. And it's like $1 for like a foot. Then you place it on and put out the little protrusion and cut it right at the tip of the protrusion. And there you go. Yeah, they just probably order the same exact thing and cut it to lengths and then put it in a package and sell it for $10 for like 3. Whereas you can get feet and feet of this stuff for like less than $1. Yeah, so anyway, it's medical, it doesn't need to be food grade, but it's just clear silicon rubber hose. And I have plenty of this stuff because Burn the Hose uses rubber subs. You guys smell toast? All right, let's put this thing away. So anyway, on this circuit board, I gotta go over and read chat. I have to actually like actively go over and read chat. Good grade. Yeah, you don't want to get that lead on a non-food safe surface. Oh, wow, all that for this. That's it. That's it. That's all we glean from removing that entire thing, huh? Son of a bitch. Okay, so where's power coming in? Power comes in through this cable in the middle. The middle connects to what? That's a positive power plane. That's a big one. That's a big positive power plane. Power plane. Wait, why does plus go all the way around? Wait, no, was I looking at minus? I was looking at negative because I'm smart. Okay, so power's coming in over here. And over yonder goes to over yonder. First stop, diodes. First stop, diode. First stop, diode. Okay, so let's just start reverse engineering then. Oh, the pile of solder was where my wrist was sitting. Great, cool. Let's just rub solder into my skin. As if I haven't been exposed to the goddamn stuff for nigh on too many years. I'm like the poster boy for actually following the safety protocols. Like, you guys might dabble in soldering every now and then. I see it every day. I smell it every day. Arrow. Thing about schematics is that they are hieroglyphics. We are actually that looks terrible. We are actually communicating something to somebody else. So in doing your schematic, generally functional flow should start from the upper left and go to the lower right. That's generally what you try to do. You're not going to achieve that at all times, right? It's not like writing a sentence. But generally, you want to communicate inputs on the left, outputs on the right, and a general flow of sort of the language of the schematic. It's a little bit of an art form, but it's definitely something to worry about. Like, you want to come up with your own standards and stick to them. One of the things that I tout here is if you've got signal lines going around and going to various stuff, when you cross over one of these lines, there are a couple different things that you can do. So if you have two lines that cross, this is not connected, or is it? there's a convention to these things. Some do this as if your schematic is a circuit that's laying down on a table. Others do it this way with no dot there or no marking at all whatsoever. And I think this is the way to go. I avoid four-way junctions. So this, with a dot, is not something that you should do. What you should do is something, rearrange it in such a way as to do only three-way junctions. And that may seem a little bit weird, but that means that if I have two traces crossing over one another, I have not made the mistake of not dotting it. Because under my scheme, if you forget the dots, that still looks like two traces connecting to another trace. Yeah, do what Forrest Mims said to do. That's a good way to do it as well, because Forrest Mims, I've seen Forrest Mims has been referenced in stuff like modern forum posts that I see. I think I was browsing Reddit last night, and I ended up in one of these circuity kind of forums, and they were saying, like, just read Forrest Mims. Like, he's a very good way of explaining how things work. But the thing is, you just stick to those principles, right? You come up with stuff like that and you stick to that style, and your schematic is consistent within itself. It's just like making a comic strip, or a comic book rather, or just any sort of work of fiction. You want to stick to your own narrative. This is a very bad looking diode symbol, and I don't like it. All right, so anyway, arrow pointing upwards, that's our VN. And then we have immediately we hit a diode. These are just reverse protection diodes, I believe. We immediately hit a diode, and then what? Then what did they say? So power, let me get a pointing tool here. Power coming in from up here. Actually, which one is it? Yeah, so it's this one. It's not easy to see that via, but power comes in here, and then we have a diode, and we see the band on the diode represents that line with the arrow. So through the diode, and then we hit a 10K resistor. Father, how do you know that that's 10K? It says 103, which is not 10K. Well, the numbers on surface mount resistors are great because they just tell you what it is. The numbers will tell you exactly what your resistor is. So 103 means a 10 with 3 zeros after it. And you could make that into an equation. You could say, oh, that's times the number of, who cares about equations? It's the number of zeros. Just think about it that way. So 10 with 3 zeros is 10,000. So that's 10K. It's easy. It's so easy. You don't have to memorize like colors. You don't have to like argue with your coworkers about whether or not something is violet. It's just 10K. And that goes to this sort of stupid juncture of about 1,000 junction of about 1,000 components. What the hell is that? Well, it also goes to the voltage regulator. So diode, resistor, capacitor to ground, 10K going across two leads of our what looks like a regulator, a power regulator. I just get a voltmeter out. Yeah, that's annoying, but it's the way to do it. Yeah, I do this with a mouse, no drawing tablet. I've gotten good at it. It's potentially very confusing to the next guy to look at your drawings. I worked in 10 years at a joint where we all had to have the same style of schematic layout and all that stuff. And we had to interpret other people's and translate them into our own. So I have a lot of very specific opinions about how to put together a legible, neat schematic. I isn't smart enough to remember colors. Yeah, I never memorized the Roy G. Biv resistor thing. I did once for a test, and I don't think it did very well in that test. Because I was just like, just use surface mount. Like, shit. Stop it with this through-hole crap. Okay, so we need to figure out what this regulator is so that I know what to put down on the page. And I'm guessing it's an SOT223. Well, no, this is a different package than SOT223. What is this one again? This one is SO323. We can look it up. We'll look it up. We'll look up the surface mount package, and then we need to get whatever numbers are on the front and see if they correlate in the surface mount component Bible if these correlate to a specific, I'm hoping 3.3 volt regulator. I need to get closer. Prepare for earthquake. Oh my God, there's a meteor coming for Earth. Ah! Okay, we're a little closer now. Uncomfortably close. There you go. BLP11. Or 1.1, I'm not sure. Voltage regulator will be important to know if it is a 3 volt regulator versus 5 volt. Probably not important. What are you talking about? No, that's everything. Skynet is targeting Philly. No, listen, the voltage regulator is everything for what we're doing because we're trying to match whatever voltages are coming in here and being read as current with our own circuit. So we want our own circuit to work in that range. So BLP11, it's probably an LDO. It might be adjustable because there's that 10K resistor right there. But this is like the most important part of the circuit because it's what's powering everything. BLP11. And then we need to find out what the package is because it's going to be hard for us to find. Remember, there's no like overarching like governing body that tells all the manufacturers exactly what they're supposed to produce. There are standards, but then where there aren't standards, there's chaos. And so in electronics, with stuff like voltage regulators, you have a couple different packages that they could fit into. None of the markings are standardized in any way. You have like 2 or 3 letters on the thing, not like a full part number like you do with larger electronics. They don't have room for all of that. Although, you know, the laser markings have gotten really good. I really would rather these manufacturers actually give us some data about what we have. But we're forced to kind of look up something that's been muddled. So SMD packages. I mean, at least this thing uses components and it's not just one like epoxy drop IC. The big glob type thing. So I don't think we're SOT323 because we have a tab. SOT23, no. SOT89, we don't have that square profile. I think we're somewhere else because we have a big tab on the top. Yeah, so we're not, maybe SOT323, but I don't really think so. We need a different guide. The definitive guide to every single package type in surface mount electronics, and it has like 5. I'm gonna cough. Oh, that was a meaty cough. So 223, I really don't think we're SOT223. I mean, we might be safe looking it up, but this is a slightly different variant. It's not quite. Maybe it's got a smaller tab, that's for sure. It's like if it's an SOT223. Maybe it is SOT89. Yeah, I guess it is. It just doesn't look like that from first blush on the microscope. So when we look here, SOT89 with its sort of gold brick appearance seems to be correct. The oh bother method? McGurk's Tweaktown method. Nice. That's a good Twitch name. Well, yeah, a lot of the part numbers are going to be vague. We only have 2 digits to look up the whole thing. So we SOT89 and then BLP11. That's not what it is. It's not an NPN transistor. What? What? Wait a minute. Huh? BLP11. Huh? NPN transistor? Yeah, maybe it's Zener. I don't know. Hold on. Let's take a look. It doesn't look like it's Zener, but that's just reverse protection. The initial diode that we saw. from Nexperia. 80 volt, 1 amp, SOT89. This thing can be powered up to like 40 volts. NPN medium power transistor. High collector current ability, 3 current gain selection, blah, 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 blah. 1 amp collector current. No, that center pin is for both of those pins, so. I love how they decode, like, just do BCE. Can you just do BCE? You don't have to, you can make a new drawing. That drawing is so simple, you could relabel it. Why do you have to do it this way? Oh, pin 1, E, emitter, pin 1. Pin 2, collector, pin 2, pin 3, base. Okay, so, okay, so that makes that 10, that recontextualizes the 10K. That makes sense now. 10K going from base to collector. So that is a typical switching transistor configuration. So we've got, I'll just do this at a right angle, and then we have our resistor going up to the collector, down here like this, and that. One of these. I missed. I'm off. I'm off by a lot. It's terrible. The worst drawing I've ever seen in my entire life. This is dog shit, and you know it. You fuck up. I'm sorry, I blacked out for a second there. What's going on? And then, where is that going? The other side of the 10K. Is that going to, it's going to ground. So I went the wrong way around. It's got a capacitor to ground. I screwed up again. I'm so sorry, boss. Let's get rid of this. And then we have a pull down. Mysterious pull down to ground of a 10K. Wait, that's not right, is it? No, because it goes from the collector. Okay, so it's got, what the, okay, things are weird. I'm going to figure this out. I think what we had before was correct. Oops, that's what Control-Z did. We can keep that up. Sometimes people come in here and they ask me computer questions, and it's baffling. What do you think I have to say about computers? Are you okay? The safe answer here is no. Yeah, exactly. At least it was better than the diode earlier. It's coming through nice and neat. For some reason, we have 2 capacitors here. One of them goes to the emitter, which is the pin all the way on the right, and ground. That makes some sense. So whatever's coming out here, we also have a capacitor. And this is a ceramic capacitor. It does not have polarity. So polar capacitors look like this. And you connect them in one direction. And you mark this with a plus. And if you accidentally put in a polar capacitor, you know that the plus is up here, but you mark it anyway. We've seen variations of this in people's circuits before where they put down this symbol as like a ceramic capacitor. That's a no-no. Ceramic capacitors are like this. They do not have polarity. And if you want the nuance and the differences between all these components, you can go look them up. You can go look it up. You can go look it up on your own. You can go fuck yourself. Okay, so the collector, for some reason, is not connected to power. It only has that 10K to power. So I'm not really drawing it correctly at this point. There's something else going on there. The 10K to V in, and then on that side we have a diode facing, well, W7. I'm tempted to think that that's a Zener diode. What would that 10K be doing there? Because like here, we would have like, we'd have a diode, or sorry, we'd have a capacitor to ground, but then we also have a diode or a Zener, which would make sense in this configuration, to ground. So is that a Zener? It says W7 on it, and it's an SOT. What is the package size? I should run a Twitch game show. What is the package size of this component? SOD323. What's the board say? SOT323. Ding, 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 ding. Oh, we have a winner. W7 SOT323. This gets into like these lists of components where you have to go to one that like near enough this makes no difference. Who's that package size? I'm gonna get the calipers and we'll give you one measurement. SOD323. W7. I'm gonna need that W7 on my desk like tomorrow. So if you can get to that paperwork, that'd be very nice. Thank you. Thank you. All right, I'm gonna go get a cup of coffee. Voltage stabilized diode, 4.7 volt. There we go. That's our buddy. From Diodes Incorporated. It turns out the design of this thing is actually pretty good. They actually did an okay job designing this thing. This cheap little sensor. You know, you expect it to be like bottom of the barrel, like total unknown components that they can get like a truckload of. But this thing appears to have been using not terrible components. There's something called a shunt regulator. Yes, I know a lot about it. Listen, I'm not sure if you're aware. I know a lot about electronics. I know quite a lot about electronics. Let's look at the data sheet. I come from a perspective of ignorance just so that I can relate to people watching the show, but I have been embroiled in electronics since I was like 12, and I've worked in the industry for quite a long time. Planar die construction. I'm sold. I'm gonna buy this now. Let's see. What do we got? It's 4.7 volt. And are they gonna display it as are they gonna show it as a Zener diode? No, they just gotta call it like a diode, huh? Oh, surface mount Zener diode. Yeah, okay. Okay, so if it's a Zener diode, then we just take it and we go. We get rid of this. We don't need this in here. And I take this and I go burp, burp. That's now Zener diode. And I can just say 4.7 volts. You see, when you bake a diode for too long, it has different properties from your typical diode. I'm not exactly finding that specific part. I'm finding all kinds of goofy references that don't match up. We got it right here. It's like very definitive that we found the right part. Although this one's SOD323 wide, it is this part. I mean, we basically found it. It looks exactly like the right diode just by looking up W7 and then SOD323. We found our buddy. So D2, this one up here, is there just to protect this circuit against being in reverse. And then D1 is there to regulate everybody to 4.7 volts. It has to have been a few moons since I was 12. Several, yes. That's safe to say. Oh, you're looking for the voltage regulator? It's not, it's a transistor. It's an NPN transistor. Okay, so we have a Zener diode that's essentially regulating this thing to 4.7 volts for a variety of inputs. The transistor goes into pin 1, where its collector connects. That's a strange little setup there. And then from there, we have this stuff. But once we get through this, we will be good. So this should be rearranged a little bit. I don't think this is exactly correct. But when this goes positive, what's getting connected there? Hold on, let me just take a look here. Yeah, I mean, that's pretty definitive, as the collector has these components on it, and it would look a little different than this, I guess. Strange one. Okay, so how would I redraw this? We got this going into a diode. And then that goes into a 10K. With this below it. Like something like this. And a capacitor to ground. And then we have just a filter. Maybe the filter after the Zener. So we have the Zener upside down. Zeners are upside down because when you reverse bias them, they have a linear element to it because they baked a diode for too long and discovered that if it's above a certain amount of reverse current, it will allow current to rush through and keep a constant voltage level. This is just a filter. Like that. I'm not certain what this is doing. Is this some kind of reverse protection? I don't think so. Because that keeps it at 4.7. And then you've got 10K. Is it overcurrent protection? Like if there's too much draw, it dumps it out to the ground? One of the text syndromes. We all want to be the first guy to say what the answer is. I know, everybody rides along with this. So, I mean, I guess that produces our 4.7 volts. Well, we know what the voltage of everything is. It's 4.7 volts. So we can actually use exactly the circuit that we're seeing in the stuff that we looked up, which is kind of cool. That's kind of cool. We can use almost exactly this circuit and we can power it off that voltage regulator. We can just use this. Because then we'll get something like 0 to 4.2 or 1, and that might be good. I don't know what currents they think that the load is going to experience, though. Or what our shunt resistor actually is. But now we need to look at the shunt resistor stuff and see what's going on. And then we'll, of course, put numbers to it by actually testing the circuit. And we'll know what we can do here. Yeah, see, like 3 to 44 volts for the LT1637, and then that works out to 0 to 2.7 volts on that. All right, so we don't need the other diagram. We don't need this one, the confusing one. I think that's overcurrent protection, but I'm not really certain about that. I don't really know what's going on with this. I've seen stuff like this before. We maybe need to just like look up something about that, or maybe, and I don't know if that's totally correct or not. Maybe we have some other type of component sitting here. But BLP11 and SOD89 or whatever led us directly to the transistor part. I mean, it was pretty definitive. I'm not going to second guess that too much. Motion detected at the front door. We looked it up and we found BLP11, which is BCX56. Yeah, BCX56. I would say that's incredibly definitive that it is, in fact, a transistor. It's an 80-volt transistor. They only have 321,000 in stock. So just put some of the word salad in there and see what comes out on the other end. Voltage regulator circuit. This is the number of components that we have. That might be what we... Wait a minute. Wait a second. Oh, no, but that one goes to ground. More like that. I don't know. Kind of like, eh. Not really. I'm not seeing that. Hold on, I'm gonna cough. Let me double check the pins here. A crystal triode, as AliExpress listing called it. I do think I see the AI hype winding down, although I already said earlier that I don't want to talk about AI. I don't want to fucking talk about AI all the time. But yeah, I do see it. It's cooling off because everybody's starting to realize how dog shit AI is. Do I want all of my drawings to look like airbrushed pieces of shit? Do I want all of the responses to be just this sort of mealy mouth business speak that has absolutely no like ball sack to it? No, it sucks. AI sucks. Fucking hate it. AI is useful in things like electronics, where you have something like a motherboard, where you have a very complicated system that needs to go together with considerations that are sort of superhuman. It's like one person can't be expected to run all these traces from one end to the other with any sort of efficiency because we're a puddle of like meat pudding that has electricity in it. And so you leave it to something like AI that can resolve all of the sort of like question mark cases that you might have in routing traces and making them all come out with the same amount of resistance and stuff like that, while considering EMF and a bunch of other bullshit. That's a perfect job for AI. You just make a robot do that shit. But when it comes to art and culture and literature, I'm not a big proponent. All right, why did that even turn on? Let's turn that off. That's distracting. Okay, so let me just double check here. We have a Zener diode, which is going to ground. We have a center junction and a resistor that goes to power, and then that goes to the collector, but the emitter... No, that goes to the base. The collector and the base. Base is in the place. The tracks, the base. I think we do have this circuit. I think we have this one right here. So that's how I need to be. Where does the emitter go? Yeah, that goes to the circuit. Okay, yep, that's what we have. So here's the deal. This is what I just did. If you guys didn't catch that, if you are new to like reverse engineering and reverse engineering electronics, something that I've done for a long time. 10 years of my life, I worked for the FBI as a contractor, reverse engineering terrorist electronics. So anything goes, you know? What did I do in order to reverse engineer that fairly simple voltage regulator, but it's not something that I typically work with? I don't like using like Zener diodes and stuff like that because it's dumping a lot of current. You use like 7805, you're dumping all of that to heat, and some of the other like low dropout voltage regulators are good too. With a Zener diode, I feel like they're a little bit more whimsical and sort of less respective of the rest of your electronics, but whatever. We have a Zener diode circuit. So what I did initially is just take a look at the topography of the chip, of the circuit board itself, and see where power was coming in. All things revolve around power. So power is coming into the chip on the center trace for ground, and it's coming in on that trace to the right. So that pin on the right there, and I follow that trace, and I follow the trace around the board until I get to a component, and that component is D2. Now D2 is the first thing in line with everything. I know about protection diodes. It says T7 on it. I could look that up. So you look at what is connected, and then you look at what the parts are. And the parts are labeled with part numbers, and they have packages. The same component, T7 here, could be put into a different shape of thing. So you could have a round body and 2 wires coming out of either end. Or you could have a little square with a couple lines engraved on it. That's the package of the electronics, and that'll tell you a lot of information, because generally the markings on surface mount electronics are the Wild West. Anything goes. So sometimes if you look up a particular package, you will have several things that are T7 in an SOD323 or whatever the hell package this thing is, you'll have several components, and you'll have to look at what those components are and make your best guess as to what it is. Now, for me, I know that this signal is coming in. This is a power signal coming into the rest of the circuit, so this is just a protection diode. This is just a flow protection diode. And make sure that if you hook this thing up backwards, it doesn't immediately explode, or this explodes and you replace that. So anyway, that's coming in here, and it goes down and it hits this resistor, and then it hits a capacitor, and then there's, what's this? This one is a big thing there, and that looks like a big plane, and that connects to this giant plane. See, the little dots are vias. They're what takes the signal through the circuit board. And that goes to that center pin, which I know is ground. So that's our ground. And so we have a capacitor going to ground. That's generally like a high frequency filters will do that. And then we have another capacitor going to whatever this is with an output, I guess, to the chip. And then we have this package here. This was a unique package. I thought it might be a voltage regulator because you generally have in ground out. But you can see it's not really connected to ground. So something else is afoot here. We look at the package and we determine that it's an SOT89 or whatever, SOD89. And then we look up the part number on the outside. And what we found was a sales listing for a particular NPN transistor, an 80 volt NPN transistor. Well, that's weird. A transistor in our voltage regulator? I haven't not ever heard of that, but it's generally not what you'd find. It's not quite what you'd find, I wouldn't think. Well, it's more common than you think. It's just that I haven't dealt with that very much. So BLP11, maybe that's something else. We looked at all of the Google results, and the first like 18 results are this NPN transistor specifically. So look up that NPN, figure out what the pinout is, and then diagram this out. And once I diagrammed it out, it was not readily evident that it was a common circuit. It looked like a mess. And that's generally what you get with the first draft of the schematic. It's going to come through, and it's not quite going to look like the right thing. This doesn't quite look like the right thing, and I think I got some details wrong in it. So in order to make this make more sense, I looked up the components that we have. Zener diode, regulator, circuit, NPN, porn. No. Just that. We looked that up, and then I ended up finding a bunch of different topology. This is my new word, topology. A bunch of different circuit layouts that could potentially be our regulator circuit. And they're starting to look a little bit more familiar. We're starting to see a lot of the components that we actually have in the fray. We've got resistors, we've got Zener diodes, there's actually a capacitor on it. But from here, we jump out and redraw the circuit so that it looks more like actual stuff. Very nice of them to add reverse polarity protection. Yeah, I think they have a lot of returns from ones that people have blown up. So I think this is they're mitigating the amount of returned components that they have by putting in a protection diode. Because it says on, I think it was the Amazon, was it Amazon or was it was either Amazon or Alibaba. It said frequently returned. I burned up a bunch of resistors and LEDs over the years. That's the extent of my terrorist electronics. Well, you're not alone. Very nice in that reverse polarity. I blew up a relay module the other day and had to replace 10 optocouplers and 10 SOT22 transistors. That's insane. Yeah, you got to be open-minded, I suppose. What I did is I put it in as a diode first, and then we looked up to see whether or not it was a Zener, because it was definitely put in as a Zener diode. So there's a little primer for you. I don't know if I was a little bit too discombobulated when I was explaining that, but that's the process that we go through when we reverse engineer stuff. You look at the initial power input, the components, then you look at how they're structured, then you get anything down on paper, then you look up circuits that function similarly. And that can give you this, and then this is what you would put in the report or in your final schematic, because this is what communicates to other engineers. Other engineers go, oh, I've done a problem like this before. Or, oh, I know to look up this kind of thing. So I think that was a very definitive and easy to follow sort of process. So now all I need to do is get it to look like that kind of circuit with the same components. So we have our V in over here. Oh, God. Hold on. Let me zoom in a little bit. Well, I kind of want to look at both of them at the same time. So V in, and then we immediately go to a protection diode, which might be just like a Schottky diode. That's a weird diode. There have been times when I've done schematics where I just put like a little pool of components together. All right, what did that other one look like again? I'm going to pull this up on another monitor. Pulled it up on another monitor. So from there, we can go down. With a 10K. And then we have the collector. Now the collector says it's on the other side of the 10K. Let's double check that because I could have gotten something RAID. I could have gotten something RAID. Science Streams was raiding with a party of 4. Sorry, I'm in my own head right now. I just did a whole primer on reverse engineering. We're shaving a yak, and I guess I have to take a moment for all 3 or 4 of you. Science Streams, hope the project's going well. It's not. We're having a good Friday today, though. We're having a nice, easy Friday. The extent of the yak shaving, get into somebody else's head. That's what I'm trying to do. How's everybody doing? Hey, Science Streams. So anyway, here's what we're dealing with. I have been working on Eurorack stuff for quite a while. I've been building my own synthesizer modules, and they're not really my own. They're other people's that you order the parts for. So that's this thing over here. That's this. So I've been building a synthesizer. It's been a trip. There's been a lot of stuff involved in this. Like building somebody else's circuit still isn't the most easy thing in the world when you need to like calibrate it in the end. And I've been building a lot of big analog electronics things too. And it's been going okay, but it's not been perfect. I have, in addition to that, I also have a synthesizer module that a friend of mine bought, and he loves it, only it's broken because he plugged it in wrong, because it's extremely easy to plug in wrong. So he plugged it into his synthesizer wrong, and he broke his M303, and it exploded, and he died. So I'm going to get this working again so that I can finally memorialize Dave. Now, Dave's still alive, unfortunately, but you must have heard of Sid Heresy. Yes, I have, in fact. I think they've been in the show quite a bit. This thing is broken, and I've gotten to the point in reverse engineering it that I'm ready to cry. I need to get something that actually can test all of the input signals to this, and I don't trust my synthesizer because I built it. So what I'm doing is I'm building this thing, and this thing is a circuit. Well, it's a modular synthesizer module testing module. But in order to build this, I need a power supply. And the power supply is rather important because I need to see whether or not I am arc welding components together. So I need a current monitor. So the current monitors I've discovered are low side current monitors only. That's pretty much the only one you're going to find out there in a package like this, because everybody does low side current monitoring because it's cheaper. It uses less components. They were able to boil it down, and you can monitor higher voltage supplies without blowing all your shit up. But because we have a common ground on everything, no matter what power supply design I use, we all share grounds, because that's just how electronics are built. So I need to reverse engineer one of these current monitor modules, and I need to make it into a high side current monitor instead of a low side current monitor. So I need to take a look at this part of the circuit over here and figure out what voltage this thing works at. This is what's called yak shaving. This is what's called yak shaving. We've been the very definition of yak shaving for months and months. And I'm so frustrated at the fact that we are now shaving atoms off of this yak's ass. But that's where we are. That's where we've gotten to. It's out of control. I've lost control. It's just a wagon rolling down a hill. There's nothing we can do. So I did a whole primer on reverse engineering and how to reverse engineer, and you'll have to rewind if you want that. Sid Heresy was here the other day. Man, I wish I could put like custom tags on people so I know who's doing what. Sid has been soldering Eurorack for weeks. Yeah, I've been at this for a couple months, and the thing that I love about the Eurorack modules is that they basically, first of all, there's lore behind all of these things. There's like a history behind all of the modules. Oh, that guy does this person does that person went crazy, that one's a Nazi, like all kinds of lore. This one transitioned. It's just insane, all of these creators, right? excitable oh bother reverse engineering. Maybe I'll make a YouTube video at some point where I can organize my thoughts a little better. But I just did a whole thing on reverse engineering. You'll have to rewind. All of these modules have like lore behind them, and a lot of the time it's that somebody had a great career creating modules, and they went and their brain, and then they went okay, I'm done, I'm out of here, and they just walked away from the whole thing and said, here, you have it, do whatever you want with it. And so you get these modules that are for sale from like a company that are exactly a copy of somebody else's module because they said you could do that. They're just like MIT license, you can do whatever you want. And then the storefront went, okay, I'm gonna copy it exactly and release it. It's like, wait, shouldn't you like make it your own a little bit? But then on the other hand, you get places that sell the circuit boards, the printed circuit boards, and they sell the exact printed circuit boards from like a $500 module that doesn't have any components on it. And then you have all of the information on the internet, and you can do all the programming and the tuning and stuff yourself. And so you put together this musical instrument from nothing after ordering about 7,500 parts. And that's really where I jumped into the modular synthesizer stuff. I was like, that's really cool. You basically buy a circuit board and they say, good luck, asshole. And then it's up to you. I love that. They all have interesting characters and backgrounds. I bought a power supply board, and then my buddy Julian was over, and he said, don't buy anything from that guy. I'm like, what? He's like, don't worry about it. Don't return it. Don't worry about it now, but just don't buy any new stuff from that guy. I'm like, why? And then he opens up a website, and I read it, and I'm like, oh, fuck. Like, yeah, no, I'm not giving that guy any more money. Holy shit. Okay, so we have a Zener diode circuit here, and we just need to resolve what goes where. So I need to take a look at what the collector, well, it's BCE, base collector, so it's base collector on those two, and then emitter. And so the emitter is actually going to the rest of the circuit, and it's got a capacitor. So we have on the collector, we have the resistor going to the oh, it's collector to, wait a minute. Collector, base. So yeah, that goes to the base. The tracks, the base. So it's something like this. And then we've got a transistor here. Got a collector. A emitter. Where's the arrow go on this one? It's NPN or PNP. Hold on. NPNP. NPP. PP. What window is up right now? What the hell? Yeah, look at that. Smart detection. Neat. Look at what got caught. Best viewers on blah, 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 blah. That's nice to have. I do appreciate when they show up and I get to nuke them. It's more fun. You get to do target practice. It keeps me primed for banning people for being stupid. But nobody's really that stupid in my chat. Oh, that arrow is going to be tough to draw. That's not a good arrow. I don't think I like that one. I don't like that arrow. It's not a good arrow. Apparently this is a common Zener diode circuit, and I don't know. I forget what the purpose of the transistor here is. We should read up about it. We've got all the windows open right now. Fine control of the mouse. If anybody denies that I am in fact a gamer, I submit to them my ability to do schematics on the air. Exactly. I only have 2 human mods and auto mods. I've never needed moderators, basically the way that I structure my mods, because I don't like moderation. I don't like to have stuff get censored. All we get are view bots, right? The internet isn't as toxic, at least around these corners, as they used to be. All the kids want to go to the gamer streamers to be racist. We don't get that kind of thing here. And so we don't need moderation. All I need is somebody to have half an eye on whether or not a bot is posting something stupid. Son of a bitch! There goes one right immediately following it. What is up with this shit? It's as if they heard me. You sons of bitches. Amazing. Just amazing. Just what I'm talking about, not needing moderation. Usually chat's up on screen. It's just being kind of stupid today. But yeah, I have like 3 moderators, and they're just people that I've seen who are responsible in my chat and have sort of an extra mind to do moderate-y things whenever necessary. But generally, there's supposed to be 1 moderator barely paying attention to the stream. I barely even get that. But chat's super slow, so. A 233,000 astronomy forum on Google Plus? Holy crap. That's insane. That sounds fun. It's good to see you, Astronomy Show. Yeah, the Knowledge Fellowship people we occasionally get coming in here, which is amazing. You know, a lot of these really smart streamers are doing the Knowledge Fellowship thing. It's good to have a little bit of a community. I think we have this exact circuit. I think this is exactly the circuit that we have. So we can read up about exactly what this is doing, because I don't see these very often. Somehow Palpatine returned. Somehow we're regulating to 4.3 volts of this thing. Actually, wait, is that? Yeah, the emitter goes directly out, and then our Zener should go from base to ground. Where did our circuit go? Oh my God. No, it's right here. So yeah, base to ground. Okay. That is exactly the circuit. Crazy town. So yeah, this is exactly the circuit that we have. So this gets a capacitor here. And then I don't like doing a ground rail. I always just give individual, you know, hollow point down to ground. That's just my own style. All schematics are going to have somebody else's style to them. People will structure schematics in their own way. I generally try to go upper left to lower right, as if you're reading a document, for input to output. And then sometimes, in order to get everything on one page, you want to like sneak power into a weird spot. But generally, you try to follow that. I don't do 4-way junctions, because if you forget to put the dot down, it can look like two traces passing over one another. So instead, I just never do a 4-way junction. And that also keeps you from drawing like a swastika by accident on your schematics. Unfortunately, lines pointing out from one another at a right angle can tend to give you things that look a little bit too much like symbology. Ephemeral ground is nice because it makes it much neater. Is that what is there a specific word for what I'm doing? Yeah, the rail to rail drawings are more like system diagrams for like industrial processes. They'll do those rail to rail ones. I don't like doing that. I would rather just have little arrows and stuff, and then draw your circuit structure to look more like what's in a textbook. You're trying to mimic the structures that engineers know about, because you're Darmok and Gelating known references between engineers. Oh, I remember that class. 4.7 volt. And then this on the output has just another capacitor, just a little high frequency filter. And that's just to be nice. I don't know why you see so many caps on so many products. I guess products see a whole bunch of different environments. That you can't really predict, so you need all that filtering in there. But when we DIY stuff, we'd never bother with all of these capacitors. The things I've seen. Takes drag from cigarette. This is our circuit. There are many like it, and that's because it's effective. So that's the initial power input for this device. That was a nice little lesson in reverse engineering. I could almost make a YouTube short out of that. I could make like just a quick little thing about RE. It is an art form, but it's also an experiential art form. You need to have like a little bit of miles under you working with circuits in order to understand how to structure things properly. So let's visit this webpage and let's just see what they're trying to teach us. Oh my God, I can't zoom in that much. The transistor Zenage we got some Zenage all over this circuit. The transistor Zener voltage regulator. The thing about Zener diodes here, Zener diode. Please, AI, please get out of here. Everybody is so tired. We're so tired of you and your shenanigans. current to flow in both directions with specialized flowing in one. Basically, they baked it too long, and so the diagram of the allowed voltages end up becoming a sort of a linear thing. So the Zener reverse voltage breakdown, this is volts and current. So you get to a certain point where under forward bias, a regular diode suddenly lets everything through, right? And that's usually in the 0.7-ish voltage range. When you're testing to see if something's a diode, you poke it with the probes and you get a voltage of like 0.6. And you know that that's a standard diode, right? With the Zener diode, unlike regular diodes would continue, I think, like linearly until a breakdown voltage. The Zener breakdown is more linear. And what that does is it actually keeps you within a certain voltage. So if you've got more volts going in, you've got enough volts going out that it's going to hold that voltage to a certain extent. It's a weird thing. It's a weird phenomenon, but it works out in that we can make voltage regulators out of them. They're not particularly efficient because all of the extra volts are just being dumped into ground. They're just being allowed to flow through and you know, break stuff. But whatever. But if you put a Zener diode on a line, you can lock it into a particular voltage. If we use, let's see, a voltage regulator simple circuit that uses Zener diode as the reference voltage and a transistor as the current amplifier. So that way you are not relying on the dump. You are giving it little bits, like a little bit of current and not overloading it. And then your much more robust transistor is able to allow that current to flow in. That's essentially what we're doing. So what's happening in the circuit is that we've got through this 10K ohm resistor, we have, okay, so hold on. I don't actually like it being structured this way because this doesn't communicate it right. I would rather have this over here, or even off to the side elsewhere, and have our Zener diode. Why is that not clear? I swear, Paint unchecks this for you sometimes, just to frustrate you. They want you to use Paint 3D, so they uncheck the little I want it to be a clear selection box. So what's happening here is that we've got power coming in, we have a reverse protection diode. So all that's doing is dropping the voltage by 0.7. It might even be a Schmidt trigger? No, Schottky diode. Is that Schottky? It's basically a diode that has a very low voltage drop, and it's good for reverse protection because you have barely, you know, your voltage in is barely being altered. It does. It just changes it. I don't understand what triggered that change. It's not like we did anything weird. It's not like I closed the window. It's so strange. Anyway, so there's a very tiny voltage drop. So our voltage here is going to be just a little bit less than the input voltage. But that little bit less, only a little bit of it is allowed to trickle through. So we don't have high current going down through this node. That 10 kiloohms is going to be a current protection resistor. So like if we put a 10K on an LED, it will be a very dim LED. If we put a 1K, we'll get sort of like almost a normal LED. And then if we put like a 300 ohm resistor on an LED, it'll blast our retina out because LEDs have a voltage drop of like 1.4 volts. So anyway, we have very little current that's able to kind of squeeze through this hallway. We have very little current coming through here. And then we have a 4.7 volt Zener diode. So that very little bit of current, if it's over 4.7 volts, is going to then go down to ground linearly. So we're left with 4.7 volts on this line. And what that'll do, given the properties of this component, I guess, it'll bias the transistor to allow a certain amount of current through from its collector to its base. So the lion's share of current goes through here and creates our output voltage. I'm not sure if it's 4.7, I guess it might be. And then a very little tiny bit will go down through here to ground. And this will lag just a little bit until it charges the capacitor. The capacitor, you can basically think of it as the capacitor starts as a short circuit, and as it charges up, it becomes it starts as a short circuit. So it looks like it's just connected until the plates charge and it resists that voltage flowing through, and then the capacitor becomes an open circuit. Then when the circuit turns off, it's going to tend to pump current back out into this node until it dissipates. So all that happens here is if there is a very quick sudden change in the voltage on our line, then it will compensate for it. It'll lessen it. So that's just a filter. That's all that's doing. This is either a filter or a delay. I think it's probably more like a filter, just for any high frequency noise that gets into the thing. And that's basically how this thing is functioning. I don't know if this is 4.7 volts. I guess I need to check. But if this is held at 4.7, does that mean that it's biasing this to 4.7? I guess that depends on the properties of the transistor. Output voltage of the rectifier is an unregulated voltage because its amplitude is not constant. The output voltage of an unregulated power source may change due to load variations. To reduce these voltage, blah, 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 blah. The circuit delivers an output voltage established by the voltages of the Zener diode. 0.7 volts. 0.7 volts is the average voltage drop between the base and emitter of transition VBE. So V out is equal to VZ minus VZBE equals VZ minus 0.7. In our case, we'd have to look it up. Huh. Is this written by AI? We can measure it. We can just measure the voltage. I'll just give this thing 12 volts, and then we can see where this juncture sits. So let's do this real quick. I'll trust my wonky voltmeter to do this, since the reason we're reverse engineering this is because we're trying to figure out what the voltages going into the microcontroller are, so that we can create a circuit that will allow us to mimic that voltage going in, but instead of measuring across the low side of the circuit, we have a shunt on the high side of the current of the circuit, which means that we are able to measure our Euro rack style power supply. So this is a lot of work that we're going through, but it's a lot of cool stuff. Love the thermal camera. It's a Lepton. There's actually a thermal, I think it's thermals command. It took us a while to get a good thing on that. Was it GetLab? I thought it was GroupGets that we, oh, I guess GroupGets is GetLab, yeah. Okay, so power supply here. I guess I'm gonna use the breadboard. Yeah, it took us a while to get a good thermals going, but they're totally worth it, because when soldering, there's a lot of cool stuff to see. Okay, so power on this one. I don't really want to power up this whole board, so maybe I'll just go over here. Power and ground. Actually, just put them right next to each other and then plug this thing in. I don't think I'll blow it up if I don't have a screen. It'll be fine. We could put the screen back on too, but okay, so this thing should be around 12 volts. I think it's around 15, yeah. And it's a third of a milliamp. Very little current being drawn. So we are measuring between ground, which is here, and our input voltage here, 14.9. So 14.98, and then on the other side of this diode, 14.2. 9, 8, 7, 6, 5, 4, 3, 2. That's 0.7 volts for all you gaming at home. So then the outset of the Zener diode on that junction, 4.08 volts. Now my meter might be off by a little bit, but it's probably not off by that much. So it really should be 4.7, but we're really kind of getting 4. And then on the output of the regulator, that ain't right. That ain't right. Oh, that's the collector, right? I want the emitter. .48 volts. 3.3 volts. How's that look? Hey, that's pretty cool. So the 4.7 Zener and whatever particular transistor that is, we get about 3.3 volts. Hey, what's up, Syphilid 8? We're doing some simple stuff, which is nice because it makes me feel smart. It makes me feel smart when I can build something and it doesn't not work all the time. Well, if I ever need to make a 3.3 volt regulator, but I really don't need to. I really don't need to. I have LM1117s, which are more efficient than this and probably better survived. Although I think this thing goes up to 40 volts. This simple thing. Syphilid8 subscribed for 43 months. Syphilid8, hey, thank you so much. Some of y'all I know so well now. 0.6 across the transistor. It's more than, well, I mean, the transistor is biased to whatever its bias is at 4.7 volts. So whatever that thing's letting through at 4.7 volts, that's where this transistor's at 3.3. We can probably actually match that up to the datasheet. It's really at 4 volts. Where's my datasheet? Not you. You get out of here. Data sheet. There it is. Okay, so on the charts for this transistor, oh, look at that. Oh no, that's like, what is that? PTOT. The hell is, what's PTOT? PTOT, power total? Medium power transistor, standard footprint. Here we go. Collector current as a function of collector emitter. BCE. Oh, these always take me like 10 minutes to figure out what's going on. Most linear, yeah, most linear radiator. Blah, blah, blah. Don't you love it when I just completely stumble over your comment and ruin it and make you sound like you don't know what you're talking about when it's actually just my brain crumbling up all the details? What's funny is most linear regulators are just advanced versions of this. Yeah, they just have a couple little more features and like, you know, filters and things like that. They just kind of make it a little bit. Every time I look at one, I question my education for 10 minutes and then go, oh, I see. Yeah, that's exactly it. And I don't think a lot of people understand that. That or I've just worked with a bunch of really pretentious dicks in my experience here, because like the people that I would work with would instantly recognize the diagrams that they're supposed to look at, and I'm fumbling around looking for it, and they go, oh, ha, ha, you don't know that it's just right there. And it's like, shut up. Like, shut the fuck up. It takes so long for me to figure out, like, what the hell is this? Because sometimes they organize it just a little bit differently. Like, the axes are just a little different. Or, like, maybe my butt hurts from sitting on this stool for too long, and I'm thinking about that instead. I don't want to have to deal with current. I'm just looking at the VBE, I guess. But that's, and now we would have to equate it over to current and then back to voltages. VCE is 2 volts. Yeah, but somewhere on this, I mean, it's just basically that when we hit 4 volts, this thing is biased enough to keep the other end of the line at about 3.3. We measured 3.4, but my multimeter is off by a little bit because it had been in a fire. And I swapped the internals from the one that was burnt into mine because my microcontroller on my old Fluke of the same model broke. So I got one that had been damaged by a fire, and I was able to just swap the main circuit boards. And now this one works fine, but its calibration is just a little bit wonky. Fluke, I'm your father? Is that what you're trying to get at? Darth Vader? I don't understand that one. Okay, so we have a 3.3 volt regulator, so we know that our max is going to be 3.3, so we will select a op amp based on that voltage, which is good because the op amps that I got for the synthesizer stuff are also 3.3 volts, so I can just use those. I think those will work just fine. What we're doing is we are trying to characterize the circuit that is operating this microcontroller that measures current, because we want to produce a different circuit for it. We want a high side current monitor, not a low side current monitor. And since it's a 3.3 volt microcontroller, they do low side current monitoring, and they don't have to worry about whether or not their microcontroller is going to fucking explode. Yeah, it's very low resolution. Actually, if I were to do thermals again on my setup, I would be looking at some of those European or Chinese thermals, because you can get much higher resolution. Now, the color palette of this one is Lepton. Lepton is a particular color palette for thermals. And while this is a 3.5, I could have gotten away with just getting a 3.0. You can get them on eBay, and if you get them on eBay, they're about $150 for the core. The Group Gets PCB for webcam was about $100 and something too. I think it was like $70 or $80. It's not cheap, but it's a lot less expensive than you would think for thermals. Then, in order to get it onto the webcam, I used double-sided tape. The problem is with the exposed core in this, whatever socket was third-party designed for that core, it's not supposed to go in a socket. It's supposed to be soldered. In the socket, I would bump up against it, and then my thermals would fall apart. And eventually that damaged the old core, so I had to buy a new one. So what I've done is I've designed a 3D printed enclosure for it. The problem with a 3D printed enclosure is that plastic does not allow heat to bleed out. There's a particular place where you can contact the circuit board if you have a metal enclosure in order to dissipate the heat. I don't have a metal enclosure, so I put a bunch of vent openings on all sides of this thing in order to get it to work properly. But the reason that this cover is so important is there's a little physical lens that will shutter in front of the lens. Sorry, a little physical door that shutters in front of the lens and recalibrates. Because if it doesn't recalibrate, it kind of wanders off in terms of the temperatures, and then you get a wonky picture. So it puts a piece of plastic that's at a uniform temperature over the front of it, and then it recalibrates itself. And it does that periodically. That's what broke when the thing fell out. Can those optics be afocally mounted to a telescope, or does it need to be unobstructed? Afocally mounted to a telescope. The problem with that is that you need lenses that will let long-wave infrared through, and those are really expensive. LWIR lenses are ridiculous. So you may have to like bespoke. IR Pass, if you have, does that do long-wave infrared? Because this is long-wave infrared. It's a little bit different. I'm not sure. I don't know what the optics are on it. I think it's a pinhole optic because it seems to retain focus over a pretty big distance from the sensor. Yeah, it's Lepton 3.5. There should be a pretty detailed data sheet for it. I need to get liquid. I'm gonna die. But yeah, I've looked up getting like optics for this because what I would love to do is to co-witness a microscope. What do you call it? Thermals. Because I do have that second sensor. So I could put something up here with this. To get a lens that's going to microscopize one of these things, I'm not sure how to do that, or that it won't be $10,000 for the optics alone. This is a Logitech webcam put into a different enclosure with a C-mount optic and then a Nikon N lens. I don't know. It's a Nikon adapter, and then my old DSLR lens, and then that has aperture on it, and this has all the focuses, and we're far enough away from the sensor that we get a 2-foot standoff that I can get my hands and tools under, and then we get this brilliant Logitech camera resolution and frame rate out of our microscope. And if I put spacers on the lens and get enough light and my Z-axis over here, we can actually look at the dies of chips with fairly good resolution. The sensor is behind an SLR lens. There's a 4.5 available? Oh, wow. Well, I'm not talking thermals on this one. Oops, where's my camera on this one? This one's a webcam in an enclosure. This has been one of the better assets of the show because I get these brilliant microscope images. They're beautiful. But this isn't thermal. This one is, and it's like a pinhole. I don't know what focusing optics you would have leading into it. It would be a fun experiment, but the budget would have to be huge because anything that lets LWIR through. One of the cooler things is with those PIR sensors, those passive infrared sensors, you can look through the lens on those with the thermals up here, and you can see how it's lens, like the Fresnel lensing is doing its job. I need to get liquid. I don't know if I have anything. Yeah, I'm just going to do tap water for the sink. I'm going to BRB. Let's put up a BRB. Oh man, I forgot that astronomers are optics nerds because I could nerd out about optics for quite a bit. I've got a lot of optics in me to nerd out about. It's the whole engineer, jack of all trades, master of none. You need to know everything as an engineer because they expect you to do everything. So I had to know how to do macro photography in like from day one in a new job. It's like I don't know this stuff. Oh, my microphone is rubbing against me, isn't it? Have I sounded like I've been like in a pillow case? All right, there's BRB. I'm gonna put music on. Let's do. What's my glucose level doing? Ugh, glucose level sucks, but it is coming down. A paid problem solver. Yeah, that's a good way of looking at it. I'm looking for a 750 micron filter to the image of the surface of Venus. Damn. eBay, I've been looking at optics on eBay because I've been trying to make a ring laser gyroscope. I would like to get all those out again and do a retry of the ring laser gyroscope because I don't know how to focus my optics well. And then when I get the interferometry pattern, the interferometer pattern, I don't know how to read that. I need something that'll be able to read it because I want to prove that the Earth is flat. And I'll get that nice 15 degree per minute. Is it minute or second? 15 degree per minute, I think. There's a good site, surplushed.com. That sounds like a porn site. Used old optics. Damn, I should look at that. That sounds great. Hey, Niano, I'm about to do BRB just because I need to get water. There we go. Have a forklift. I'll be right back. Oh yeah, my Z-axis is in that shot. It's right there, right at the bottom. All right. You know, people who make optics, that's cool. Usually buy my used optics from people. That's crazy. You guys are crazy. You guys can't see chat right now. You can't hear, but let's get the forklift out of here. We don't need the forklift anymore. Where's that? Here. And then it's way down here. Where'd it go? Okay. Oh, I thought I turned that off. overlay BRB, and then the music. I don't currently, because I don't have a working full synthesizer, nor do I know how to use it. All right, so that should recalibrate the camera. I don't do that yet. Maybe at some point. I'm not sure if I ever will. We do every now and then. I get Julian and possibly Dave, who are my good buddies in here. They are in the educational system, so during the summers they get some time that they can spend to bring their portable modular synthesizers in, but it's usually pretty chaotic. There are some good wibbling noises that they make, but it all depends on what kind of mood they're in. It's wherever the wind blows that day. Possibly could make something that sounds cool, or we could get screeching for 45 minutes. It's never a known quantity. So it's fun to get them in there because it's nice to have co-hosts. I can have somebody else sort of distract chat while I'm working. But other than that, no, I don't typically do synth stuff. Streams. OpenSet does synth streams combined with microscopy. Microscopy, I know, but I like reading things in a weird way. It's like aluminum and aluminium and alumia. But anyway, that sounds really cool. Yeah, combined with microscopy with synth stream sounds pretty cool. What happened here? What happened to that camera? Wait a minute. Oh, it's in synth mode. Or it's in rack mode. Hold on. So go to overlays. No, yeah, rack view. There we go. We're back. Oh, Alunian. God damn it. Alunia. Alumina. Okay, so we're working on reverse engineering this voltage regulator, or this voltage ammeter and voltmeter. And in order to do that, we need to figure out where everything's, going around here. Grows crystals, does kaleidoscopes with them, and a trippy stream. Damn. Some people, man, some people are good at this stuff. They're too interesting. I can't compete. It's like Uo's lab, where he does all kinds of crazy sort of electronics projects at a breakneck pace, to the point where I am just completely like, okay, I can't do this. Like, I would not be able to keep up with this guy. It was hysterical. We met up when he was in Philly. Yeah, I can't keep up with the guy, and he's got such good numbers. I wish I could get there, but we're a little bit too cerebral for that sort of thing here. Although for me, Burn the Subs is the big one, and that's been something that I did in the past. I got 2 of those boards out, and now we're trying to cross our T's and dot our I's just right to get a really good version of Burn the Subs done. But I'm burning out a little bit on it, so we're taking a short break, and then I'll get back to all of the hardware of this thing, because we're almost done the hardware of the board. And once that's done, we jump back into Python. Right now, we're actually at a bit of a hiatus with Node-RED. My MQTT broker is broken. And until I can get that running off of my file server, where there's backups and dependability and stuff, I'm sort of out of it. So eventually we'll figure it out. I mean, BrinkGG was working on some stuff for that, and hopefully I can get into a point where I can understand what the hell I'm doing. Once I get MQTT brokered, then we can work on getting Twitch to run on Node-RED, which is not that hard to do. It's something where I have to fill out a bunch of stuff and understand what I'm actually doing. We get Twitch running on Node-RED. That means that I can have nodes that'll filter out things and route all the different interactivity layer things, so chat can control stuff. MS Paint the subs. I don't know about that. His math teacher. Julian is a science teacher, I think. It might be, he might teach math, I'm not sure. But whenever I try, like, he's always explaining to me how the modular synthesizer works, right? He goes, oh, you take this and you put it through this thing and this thing and this thing. I'm like, what you just said, what you just told me was what an RF engineer would say to another RF engineer about a radio. And he was like, I don't get that. That's too complicated. I'm like, no. You get that. Like, you just modulated a signal through another signal. That's called, like, you just used amplitude modulation. Like, what? That's it. That's it. You're a radio nerd. Like, you don't understand. You're a radio nerd now. You know RF. Not a lot of people can understand RF. He undersells himself on all that stuff. All right, so we've done the voltage regulator, right? Like we know where this thing is buttering its bread. High Potential has things in his environment controlled by chat. Uo's lab also had stuff controlled by chat, and by the way that guy functions, I have to figure that there's some easy solution for getting chat controlled stuff. We did chat control stuff back when there wasn't a lot of stuff for chat controlling, so we were able to get an ESP8266, a little microcontroller, to get into IRC and do credentials and read the chat and look for commands. And then I put that on some tank treads, and then we had the tank treads rolling around on the desk controlled by chat, and then Rabaz rated the stream with about 500 people, and I taped an X-Acto knife to the little tank, and so it ran around on the desk and tried to stab me. It was pretty cool. But like that kind of stuff, those were all individual devices. So was Burn the Subs. Burn the Subs, in and of itself, can get into the Twitch API and log in. And I want to pull that back and actually have Node-RED do that job, because we had a channel point controlled fart box, and it just made fart noises all day as people used their channel points in order to, you know, just make a random fart noise. That broke one day, and as of breaking, I thought, you know what, instead of having these individual devices with their own credentials, I'm going to put it all into one singular bot. So one Node-RED instance is going to get onto the Twitch API and look for stuff. And there's a couple projects that do that already. So we're getting those, put that in Node-RED, make it work. But at that point, I had broken MQTT. And so now I can't control my lighting and stuff. This used to be automatically controlled so that when I was on this scene, it would turn off. So it would be when I'd switch from camera to camera, this thing would toggle on and off in order not to blow out people's screens. I'm using the barn doors right now to kind of tamp it down so that you guys don't have too much of an issue. But yeah, I got work to do. I got a lot of work to do. Once that Node-RED stuff is fixed, then I can get to getting a front end that we will then program to interact with the board. And the board, hardware-wise, just needs little bits of work in order to get it functioning again. It's a whole thing around here. It's like I've got so many yaks to shave, and these other electronic streamers are like, I'm gonna throw a pickle down a heated tube and see if it'll cook the pickle. Like, it's like, oh, that sounds fun. Wish I could have fun. Okay. I'm hoisted by my own petard almost constantly. Oh yeah, this is the 3D design for the front panel. Cool, it looks just like the real thing. Whoa. Okay, anyway. I miss fun. I had fun once. I don't care for it. Oh boy, we're gonna go into 90s music video frame rate mode with this update. Happy to find your stream via the raid. Must cut lawn now. See you soon. Go. Oh, that's like expert mode touching grass. You're touching grass so hard that you're altering it. Yeah, go do your thing. You don't gotta stick around. Thanks for joining us. Okay, so what was I looking at? I was gonna look at this circuit and see what the next piece that we were going to uncover is, because we know now that there is just a microcontroller with 3.3 volts going into it. So this would be 3.3 volt, and then we probably have a ground somewhere around here. This one's pin 1. And then we look at this thing, and we see, where's our ground coming into you? Where are you getting ground from? From nowhere. There's 2 vias on the underside. So under the chip, there's going to be a couple traces where ground propagates. So what I can do is I can get my trusty multimeter. Thousands of life forms are about to be effective. Listen, if you ever want to kill billions of life forms, get into brewing. I still have all that honey from mead. I need to dump those into a pot and get some. What I do is I get the big bottles of water that they have at the grocery store, just because it tastes better than my tap water. Okay, so now we go to ohms. We do not use the beeper function. We don't use the beeper function. The beeper function will just annoy everyone. Don't use the beeper function. It'll lie to you. Ohms is the way to go, because if you're poking around and you go around like a resistor, That'll give you a piece of information about what you're looking at, and it can help you figure out where you are in your circuit. You can't get a good amount of light. It's tough because my hands block this extra light. Maybe I need to make this like hang off of something. Yeah, I started out on Twitch with the brewing setup. But nobody really watches home brewing. Maybe they do now. Okay, so that's not ground. It is. Wait a minute. Is it? Are you ground right here? 15K. Why 15? That's a funny number. Oh, because it's going through the potentiometer here. Okay, so let's look. So we got ground here. Power's here. Is this ground? Absolutely not. It's going to be one of these mid pins then. That's weird. Ground here. I wonder what the silkscreen pin is. 8M, 9M. Is it doing anything? Might just be an NC. But why wouldn't you want an NC to... You would want to put it to a pad because that strengthens the mechanical bond. Nope. 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 Oh, wait. Oh, there's a 10K resistor to ground on this one. Ask me how I know. The lighting is fine, don't get obsessive. I'm allowed to be obsessive. This is my show. Fine is the enemy of perfect. Maybe it's this one. This one seems to... Well, pin 2? No, that couldn't be. That wouldn't be ground, would it? You wouldn't do that to me. No. Never. You wouldn't do that to me. No, it's not. Okay, next. Make no assumptions. There's probably going to be a ground connection to the LEDs. Maybe it's a power connection. Maybe the LEDs are coming down from power. Rest in power, King. I could just rake the pins and figure out which one it is. What was you? Huh, weird. Okay. Okay, let's just go back to this. This. No. Nope. Nope. Okay, this is baffling. Try this pin here. Oh, okay, so it's pin 8. Pin 1 and pin 8. Pin 8. Now I don't know if I want to do the screen pins. I don't think we need to worry about those. It's just we have 3 ADC pins where our signals are coming in. So 7 and 6, I guess, are the 2 pins. Where's voltage being read from? Or is one voltage and the other's current? It might be that it's just current running directly in. So we have a 0 to 3.3 volt signal depending on what our numbers are. And we just have to match it up. We have to match up whatever number it displays to whatever voltage we're giving it. So that voltage input pin we want to trace up. Oh, this thing is still powered. Well, it's not powered, it was off. Okay, so voltage sense is on the yellow pin, and the yellow pin goes to this dot right here. And that dot goes to the other side of this 30K resistor that goes to a potentiometer that then goes to an RC, and the C goes to ground, and the R seems to go to ground too. Where else is that? No, wait, it goes over there. What is that doing? Okay, hold on. Let's take it one step at a time. So I guess I put my power pins on a weird side, but it's basically, if we're taking, let's just do that, and I can just put the screen over here. Display, and then it's going to be pins 2, 3, 2357889. 2357889. Oh no, 234. Sorry. 235678, because that's coming from under there. Two, 3, 5, 6, 7, 8, 9. I'm not going to label that. Okay, so there's those pins. And then we have VIN coming in from outside, so V. We'll call it vSense because I called VN VN. vSense comes in and says, hey man, what's up? How's everybody doing? Father, can you please tell my CTO to stop being such a cunt? No, I don't know why you would use that word. That's awful. That's a terrible thing to call somebody. Is why would you call your CTO a cunt on my stream? That's a terrible thing to do. He said fun ruiner. That's the joke. Okay, so voltage input comes in from over here and it goes to this dot right here. Where's my pointer? Where's my pointer? There it is. Yeah, I should tell your CTO to let you get back to work on getting my MQTT shit working. It's really no pressure. 30K over to this big thing here. So first thing is we're just going to draw a 30K resistor, and I'm going to give myself a little bit more room to draw. So coming in here, we hit a 30K. I should do the boxes for resistors. It's much easier when you're freehanding in Paint. So there's a 30K, and then we go to that big juncture where there is an adjustment potentiometer. The adjustment potentiometer is connected to... Okay, so it's just connected to the big plane. Why is there such a big plane there? It's so weird. It's not connected to this, and that I think is it's power. TrueNAS is retiring Kubernetes for Docker Composer in the next update. They've locked submission for Kubes since it's being removed in less than 2 months. It's like, okay, what do we do now? Do I need to just spin up an entire thing in order to make an MQTT server? It's like, what do I do? This circuit is kind of mad. This is going to go together in a weird way. Okay, so we've got a 30K, and then we have a potentiometer that's just being connected like so. Oh god, that looks terrible. Oh god. Well, at least we know. So no, this looks too bad. That's terrible. Nope. Nope. You know, sometimes I use the line tool. Things look a lot nicer. I think it's because I'm zoomed out so far. It makes my freehanding a little bit more unwieldy. Let's just make sure we got space to actually build this circuit. Okay, 30K and then a pot. What's the value of the pot? They're sometimes written on them, but I don't see it anywhere. These surface mount pots are just obnoxious. So we don't know the exact value of this thing. We can tell right now what it's set to. Maybe make an educated guess. $10.3K. And where's the wiper? It's facing just about in the middle. So it's a 20K potentiometer, I'm going to say. $20 kilo ohms. Mosquito exists in Docker. You'll be able to deploy it with a single YAML file. What is it? What is any of this? I feel I feel like I'm going insane when I read these comments. I know you understand what all this stuff is. It's just like projects in Linux, right? Mosquitto exists in Docker. You'll be able to deploy it with a single YAML file in 2 months. If you can't wait to deploy it, if you can't wait that long, or I can get instructions for setting up Docker in a VM before then. I guess I could wait for a YAML file. I don't know what that is. I don't know what it is, but yeah, we can wait. Yeah, as long as I could just get my shit running. I'm just so pissed off that there are these real easy to deploy apps. YAML, YAML, yeah. Oh, that is an L, isn't it? I'm an IT. I can confirm we're all insane. Yeah, this is how you guys go insane. You guys have to process all these weird words. The thing about like TrueNAS looked awesome, right? Because it was like, oh look, I could just install Node-RED. I can just deploy it as an app. And then I'm like, wait, but is there an MQTT broker? No. Why not? And it turns out like there can't be one in the app structure because they decided to like end of life stuff that they shouldn't have, or there was some solution. They basically ran into a brick wall is what it sounds like in the end. And they really should have avoided running into that brick wall, but they didn't. So now I get punished for it, and I am unable to deploy the proper control of my Tasmota devices, as well as all other, MQTT stuff that I was going to broker. I was going to make burn the subs essentially, broker on that same thing and use that. But I guess not. YAML is a super simple configuration file that describes a deployment. In this case, Docker. Okay. And it's something that I just don't know. It's totally crazy. There's like daily planner software and stuff in those apps. People use this stuff for all kinds of weird purposes. It's like, why I want that on my file server is beyond me. Okay. vSense, 30K into a 20K adjustment, and that just lets you tune up the voltages properly. Now we get into Crazy Town, and when we get into Crazy Town, we take one step at a time. So in Crazy Town, we basically have the next thing that this goes to. Burp, 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 burp. So 4.7K, 472. I can verify that if you please. I'm coughing a lot. I think it's because the humidity dropped significantly. There's also a capacitor on this junction, apparently, and the capacitor is causing that walk around in voltages. The nightly builds are already out, and I have it running on my dev server. It'll be 10 minutes of setup once it's in the main build. That's cool. Okay. I look forward to that. 4.4, close enough to 4.7. Now, the question is, where does the other part of this 4.7 go to? And I would assume that it's going to be in parallel with the capacitor right next to it, since we saw that weird charging going on. Yes, it is. So it goes directly over to this capacitor, and then it goes over to pin 8, which is ground. So this is a resistor to ground. This is a capacitor to ground on this line here. This does not go there. It does. So it does go there. It seems like it also goes diagonally, which is a little strange. Maybe it doesn't. Maybe ground is going up there and over. It's hard to see. There's a lot of silk screens in this area. That goes there, and then that one is ground. Yes. Okay, so resistor capacitor to ground, and then it goes into the pin of the microcontroller. So if I were to measure here and here, I would get low ohms. Yep, okay. All right, so that's just very simple. And actually, I'm going to redraw this because that other resistor that was 4.7. So what we have is we have a voltage divider. So what we'll do is I'll take vSense out of here. And we'll draw it like a voltage divider. Oh, these resistors are terrible. They're very hard to draw. I should do box resistors in the future. There's a dot there. Let me come over here. We have another capacitor here. I'll do that a little lower. Capacitor of unknown value. You can't really tell what these are. You can take them off of the board if you want and measure them, but it's not really worth it. It's the adjusts. This one's 30K. Or no, wait. This one's 30K. 20K. And then 4.7K. So we have a voltage divider from 30 to 20, 30 plus or minus, 30 plus, you know, not plus minus, it's 30 plus 20, and then 4.7. So we're dividing that voltage out. So what would the maximum voltage be? I would assume it's 3.3 volts. Let's try voltage divider calculator. Let's see if we can get something here. So if I have 100 volts and I have 40K as my resistor 1, and then I have 4.7K, 10 volts. That pin is pretty robust, I guess. Box resistors and squiggle inductors piss off both Euros and Americans. Yeah, inductors are very tough. To draw, that is. What did they say? It was like 40 volts? Yeah, 40 volts. And if that's at 40 kilo ohms, then you get 4.2 volts into your voltmeter. So that pin must be kind of robust in this, whatever this microcontroller is. It says it goes up to 100 volts. But I don't know if I believe it, unless this is just, you know, a very specifically engineered pin in order to take all of that extra voltage. Because I know on a lot of the microcontroller platforms that we use, if we go over VSS, we're dead. Our microcontroller explodes. Okay, so now we can look at the current input. I'm gonna cough. God, this cough sucks. I don't know where it came from. Either I'm sick or it's just how it's dry around here. Now, if I measure the shunt with my not so super accurate multimeter, .4, .5, R018. I don't, that's like a code, because it's really not 01 with 8 zeros, right? So can we Google that? Can I look that up? I don't think it's B. I don't think it's 01B. 4-digit SMD resistor calculator. Values starting with R0 below 0.1 are non-standard. So R018 might be 0.018 ohms, although we read 0.4. Four-digit SMD resistor code R018 stands for 0.018 ohms, in words, 0.018 ohms resistance. R0. Can't start with a 00, weird. R0, non-standard, 1, and then an 8. Huh. So I guess if it's R, it's below 1 ohm. I'm willing to believe that, but my meter is not reading it properly. Interesting. Okay, well, we'll put it in as 0.018 ohms. So this would be the header with the red and the black wire. Which one's which? Plug it in, and the black wire is towards the edge, and we'll just remember that. So R and B. We're almost done reversing this thing. It's taken a little bit longer than it should have, but for the most part, we got distracted yesterday and had all kinds of stuff going on. And then today, I was able to get most of it done pretty easily. We found just kind of a cool voltage regulator circuit, and then we sussed out what voltage sense is doing, and it's just a voltage divider. They're doing the easiest stuff, but they're doing the easiest stuff with components, which is what I really appreciate about the level of technology that we sometimes encounter, where I can go in and I can fully reverse engineer something based on the components, and everything makes sense. So over here we have our shunt resistor, and it's 0.18 or 0.18. God, that's going to be really annoying. We'll just write it up here. 8s are very difficult with a mouse. You can tell I'm a gamer because I have control of the mouse. That's right. I've got those motor skills. Ladies? Stupid. 0.018 ohms. So we've got that shunt resistor in there. Let's see what else we've got. What else do we got? This thing looks nasty. I should probably have cleaned it off. Okay. One of the leads goes to a big plane, and I'm going to assume, as in make an ass out of you and me, that this one goes to ground. Oh my God. Yeah, it does. Okay. I see art. You're damn right. I love a good meticulous notebook drawing. So this right here is why this is only a low side shunt, because it incorporates the ground of the device and everything. This is why we must convert it to a high side shunt. I wonder if I could just straight up convert it. Well, let's see what it's doing over here. I have a feeling that it's turning it into some kind of a voltage, because we're sensing across this resistor, and Mr. Resistor goes to a capacitor. That goes to potentially ground. Why would you wire it like that, though? Does not go to ground. Does it go to, is that one power? I don't think that one's power. No, this one's V-Sense. Power would be way over here. If we look at this, that's power. Yeah, it doesn't go to power, for sure. What about you? No, nobody filters the power. Only crazy people do that. That's going through the 10K the other way. What are these traces doing here? It's like, look, these are like this. Oh no, that's through the 10K. Through a 10K. Keep slipping. Oh, that is ground. Okay. So, resistor. Over to here. Okay, what is this one doing? it goes to ground. Okay, so it just goes through a 10K resistor to ground. It's like this. Here's what I see. And then 10K. Another cap. Oh god, I messed up. I screwed up. And that's it. So there's an extreme amount of current limiting going on, but then we're just directly measuring the voltage across a 0.18, 0.018. I'm going to redraw that number. That number is all over the place. This shouldn't have a dot. Actually, that. Okay, so 0.18 ohms versus however many amps are running through that, shunting directly down to ground. So at 3.3 volts, 0.018, how much current is it measuring? So V is equal to IR. This is where I mess up all my equations. So V over R, so it would be 3.3 over 0.018. I'll just do that with a calculator. V3 over 0.018. 183 amps. I shouldn't put exclamation points in there because we're not factorializing it. 183 amps is the maximum amperage that this thing can read. That's insane. And it's also an extremely simple ammeter. I can't believe how simple that is. What board is this? This is just one of those normal, what do you call it? One of them normal volt and amp meters that you can get off of Amazon. And we're discovering why these things are so cheap, where we've fully reverse engineered it. And it's a fairly simple reverse engineer, to be honest. It just is using a voltage divider with a little bit of tuning in order to get the voltage into an analog input on the microcontroller. And then it uses a very simple voltage drop across a resistor in order to get the amps. Our power supply is a Zener diode that uses a transistor bias. So it's just a very simple power supply that can get very high, like it can have very high voltages come into it. And then the rest of it is an unknown microcontroller that's connected to a display. So pretty cool and easy. The problem is they set this thing up to be a low side current monitor, and we need a high side current monitor because that's what I thought we were buying. I thought I was buying a high side current monitor, but we didn't get it because I'm dumb and I ordered the wrong thing. And I can't find a high side current monitor that's in the same package. So if we can figure out an op-amp circuit that's going to take our stuff coming in, we can get it to run properly. All it's doing is, it's just, no. They're not scary. They're not scary. They're fine. It's not, you know, doing any particularly important tasks. And this thing is simple enough that it does just a great job at what it does. So it looks like we know our voltage range, sort of. We sort of know our voltage range, given the design of the circuit. We have a 0.018 ohm resistor, although that's not what I measured. Using my big multimeter, we should be able to measure that with nothing connected to it. And my multimeter is not the most accurate thing in the world, but it reads 0.4. Although then again, if I do meter to meter, yeah, we read 0.5 with meter to meter. So I guess it's out of the range of ohms that I can measure with this thing. Mainly scared of them because Amazon's such a hit or a complete miss. Yeah, I know those things can be. They could be really bad. The only problem is when we looked for volt and amp meters on Amazon, we didn't find anything that was high side. And the reason is because you need more electronics in order to do high side. So they're more expensive. And since it's an economy of scale, everything is scaled down to the most minimum that it can possibly be. All right, we don't need any of this stuff. This is actually all, except for the circuit, is obsolete. This is almost the circuit that we will produce. Only ours is going to be under 3v3. And so the equation might come out to slightly different numbers. Actually, probably before that. We should probably inject this before that. We'll make a little daughter board that will fit onto the rest of the circuit, and we'll remove the appropriate components so that I can simply put the current from the outside world into here. Hold on, let's take that. We go, whoa, 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 bop, bop. But we can't use that maximum because we have no way to calibrate this. We can't calibrate this. We have to calibrate this with something physical. I think I made something of the sort in Uni Laboratories. It's funny, all I could find was textbook results for current mirror. That's all I could find. I can't believe I have to do this though. It's so obnoxious. I can't believe I can't just find a product that does this. But since everything is like battery systems nowadays, there aren't really any. God, there's a lot of windows up. There aren't really any good results. If I do, let's search Amazon again. High side ammeter. We get the ones with the little clip-on probe. But they ignore high side. Nobody puts that in the listings. So they're all just like, hey, connect it to the, yeah, look, connect it here on the negative. DC 0 to 100 volts. DC 4 to 30. Oh, this is the one with that shunt. So I didn't get the one with the shunt. I got a slightly different one. This one has just like a bar shunt on it. You keep saying shunt until it no longer has any meaning. I don't know if this might be the same as the ones that we're using. It looks like it has a voltage regulator though. That thing down in the corner looks like a VREG. Ours is like a simpler version. It's like a bean counter version of the whole thing. Let's close some windows here so I've got a little bit more room to breathe. This has been a good little exercise in reverse engineering. I've been able to kind of show you guys what it's all about, how to kind of author and reverse engineer a circuit properly. Now, if we wanted this to exist in the 3 to 44 volt range, we could use something like this. The LT1637. Ow, hold on. Oh, I got a pimple coming in right above my beard. Self-powered high side current sensor. We don't need self-powered. We have 3 volts that we can use. Variation of classic high side takes advantage of over-the-top input capability to separate the supply IC from a low voltage rail. Owie! Oh God, it's like right where my tooth goes. Stupid thing. And of course I'm gonna pick at it until it becomes a wound, because that's how you treat pimples. What a terrible day to have a mouth. Okay, this is essentially our circuit. I mean, this is all we really need. It's just what about RS? Is RS in our circuit going to be the 0.18 ohm resistor? Will that have the same results if we're comparing from plus to minus over 0.18? I think it might. And then we'll just have our current limiting resistor as a 10K in there. Doesn't that make that a voltage divider? Because it's got the 2K going down. I load is equal to V out over RS times R2 over R1. Oh man, do we have to do a bunch of equations in order to figure out what these values are? It seems like we will. So let me just grab that equation. Oh, I grabbed half of it. I gotta grab the whole thing. And then this one we would take out and not have this here. So it'd be, oh yeah, let's just steal that whole other circuit. I need this whole thing. Hold on. We're doing this one because this one takes a separate power supply. I could get rid of the whole thing. Oops. This would be our circuit. So basically, 0.018 is what we're using here. So V out, so IL equal to V out times RS, R2, and R1. I load, that's just something I do. How am I going to deconstruct this? This all seems so familiar, but I've been on summer break and I can't pinpoint it from my memory. I've never taken a hardcore circuits class, although I do think I've been through some of this stuff many, many, many years ago. But it's all very familiar. This is just, circuit math. It's just like this. We're just doing gains. We're not necessarily doing loops. I did a lot of loops in my day. I got very loopy. So if V out goes up to 2.7 volts, what would that, so 2.7 volts, 2.7 over 0.018. And so our current at 2.7 volts, this is the annoying part where I need to bring out the calculator and do some napkin calculations. And it's very simple stuff, but 2.7 over 0.018. The engineering brain cannot comprehend these calculations without Excel. 150 amps. So I load is 150. 150 equals V out, which we said is 2.7, over, and we would like for our sense resistor to be 0.018. I'm going to put it 0.018. Because I want to reuse that resistor. And then R2 over R1. So R2 over R1, I would like to bring out and figure out what that should be. So, oh God, how do I do math again? How do I get out of the denominator? I multiply by R2 over R1. I multiply everything by that. 150 R2 over R1. Equals 2.7 over 0.018 times 1 over R2 over R1. No, wait, that just fully cancels out, doesn't it? Because I've got 2 times R2 over R1. So what did that even accomplish? What did I do here? I'm stupid. If it's 1 over R2 over R1, can I just flip R2 and R1? No, that doesn't work out that way. This is when my math brain starts to break down. Divide them both by 150. That doesn't make sense to me. Hold on a second. Okay, so this equation is annoying, and I haven't studied math in a long time. I haven't done this kind of stuff in a while. I don't even know if I was on the right track. But basically, I need to resolve R2 over R1 to come out to something that's going to give me 150 when I divide it by 2.7 and multiply it by blah, blah, blah. So with 0.018 as a fraction, this is going to have to be big values. R1 at 200, R2 at 2K. If it's 200 over 2, 100 times 0.018, 1.8, 2.7 over 1.8. If I use their values, then 1.5 amps gets me to, or no, it gets me to 1.5. It gets me to a hundredth of what I need. I need 2 zeros behind that in order to get it to the right value. Just sort of took that equation out with their values in there. No, R2 is 2K and R1 is a 200 ohms. So no, they're not equal. Ouchies. So really what I need is either for R2 to be much higher or R1 to be much less. If I do a 2 ohm resistor, is that going to blow up the circuit? I don't think it will. So if it's 0.018 times 2 over 2000, so 2 over 2000 times 0.018, oh, I don't think this is going to work out, 2.7 divided by whatever the hell that number was, 0.1234, 150,000, 2.7 divided by 150,000. I screwed up somewhere. Clear that. Maybe if this one's 2K and the other one's 2K and then that one's a little bit closer to, yeah, because we want smaller numbers. So what if they are, let's just do 2000 over 2000 is 1, 200 and 2000, 200 and 2000, so 2000, that's 1, so 2.7 divided by 0.018. There we go. Okay, so I want them both to be 2K. You did that math in your head, I'm guessing. I'm not great with math. I'm not good at math. I know math. I do a lot of math. I've done a lot of math, but I haven't done a lot of math lately, and I'm just not good at math. It's bad. It's real bad out here, especially when you're streaming and you're trying to kind of be like a goofy guy and make sure that people are like engaged and you're not being totally boring. The math brain takes a little bit to spool up, and it takes too much energy. Like, hey, wait, you should think about that. And I'm like, I don't have time to think. I'm streaming. So yeah, if they're both 2K and we have our 0.018 here, then everything should work out in the end, and we'll finally be popular. We're not using an LT1637. We're going to use an OPA, but that should be fine. So let's go get some surface mount parts, and let's see if this... Well, actually, should we breadboard it first? We should probably breadboard it first. I have no way to put 150 amps through this thing, though. That's the thing. We're just trying to match it to the voltage levels that this thing would see if it had its native load resistor on it. It's shunt resistor on it for the low side, but then this is a high side monitor. So we can have 3 to 40 volts, pumping through our circuit here, and this will output a similar voltage level to the low side. The only difference is the low side is vastly less complicated than ours. That was a hoot. I think we came up with a good solution here. Should we jump directly into the surface mount world, and I can make a little daughter board that we can transfer from one thing to the other? Or let me get up and stretch my legs a little bit. I mean, my goose is already cooked. It's Friday. I'm done thinking. I'm done with this thinking stuff that you guys are constantly doing. It's getting on my nerves. Circuit boards that are specialized for things like this. We're finally getting to the point in this project where we're starting to gain back ground. We're starting to gain back ground. All the wrenches are now put into forward mode instead of reverse mode. We would always make note of that when we work on cars. I shall cease to think now. That's like my friend with his parents. They're like, "Don't be smart," and he's like, "Okay." Like, shut up. All right, so little circuit boards that are going to take a little chip and allow me to build the comparator circuit that I want are these guys. These are just little breakout boards. These have gotten vastly cheaper. I don't know, maybe we were all getting ripped off back in the day, but I remember looking at these things in the back of a DigiKey catalog, and they were like $50, $60 for a sheet of these things that had all these little chips on them. Nowadays, you can get them for like $1. But they're just little surface mount breakout boards, and they help you build little tiny circuits and put them on like a breadboard or a perforated prototyping board. Sometimes I will use these. I mean, it would be interesting if I use these in the design for this thing over here, but I don't think I really want to. I would rather just use through hole on that, because then I can spread out. But these are good for deployment like we're doing right now, like shoving it into this little thing. But I got to make sure that these are the ones that have components on the back side. It's got spots for 4 surface mount components on the other side. Just make sure this one's that kind too. We're going to need 2 of these circuits, so I'll figure out how to build one, and then I'll build the other one exactly the same. I remember paying $50 for a set. I got like 100 from Ucell for like $9. Yeah, exactly, AV Fusion. I can't believe how cheap they've gotten. That bin constitutes like $200 back in the day, but nowadays they're so cheap. UXL, yeah, it's just like you search it on Amazon, you find whatever. It doesn't matter who produces it. This pimple's driving me crazy. Okay, so how are we going to put this thing together? You always can tell, like, an engineer of culture when you see these things in a design. Yeah, you know what's up. So I am somehow going to have to produce an op-amp circuit on this. And the op-amp circuit is not terribly complicated. There are some support components that I'm going to need. And a shunt resistor, I guess. Unless we break the shunt resistor off of... Well, we can't use the inputs from here, because one of them automatically connects to ground using the top ground plane. That just automatically goes to ground. So we'll have to have a separate input. Unless I figure something out with this. I could sever one of the traces and cut ground to that area. It looks like if I just crack this trace right here, this will be completely devoid of ground. So I'm going to get my tile cutter and do irreversible things to this circuit board. So this is a tile cutter. This thing is actually for cutting rubber tile and making stamps out of it, so that you can do tile art and reproducible, print art. But I bought this because it has this V groove. It has this beautiful little V groove in it. And so you can use that to groove out, and I probably shouldn't put my finger right there. I should go above. I can just groove out this trace right here just by pushing down pretty hard and running across. It didn't do anything. Right? It's a little bit unwieldy, but it does do a good job. It's a little slippery and hard to control versus having a knife go through it. Yeah, maybe I want to scrape that with a knife because I didn't do such a great job with the tile tool. Doesn't have a lot of room to maneuver. I started a little earlier, maybe. Yeah, it's not really cutting. I'm not getting a cut out of that. X-Acto knife that I dremeled the reverse side out of to make a sharp hook. I mean, some of the other bits might be able to do it too. Nah, I'm gonna use my Raptor claw. I would say you don't want to get a Dremel, or sorry, an X-Acto knife. You don't want to get an X-Acto knife. They're terrible knives. They're very dangerous. I use scalpels. The thing about scalpels is you can get a huge pack of scalpels. That tile cutter, by the way, that's not really ever worked properly. It seems like such a great idea, but then it's not worked properly. You can get all kinds of different scalpel blades, and they just snap into the tip. And that way, when you're working with it, it doesn't loosen itself. And you can get claw adapters. That actually almost worked. The tile cutter couldn't just get this last little bit. There we go. Isolated ground. Now we double check with the multimeter. Yeah, I don't know. The tile cutter would work if you have to sever a lot of traces and if there's room. There wasn't space for the head to get all the way in there. But now I've got like a little gap on that. It is a little bit sloppy though versus the knife. The knife is a little bit more precise. Yeah, just using a utility knife. Just use your pocket knife. Use your Swiss Army knife. Wait, I want to go from here to ground. Damn it. Ground is here. We get numbers moving all over the place. So that means we just severed the ground connection. Yeah, so that goes through there, but nowhere else. We're not going to need that resistor anymore. In fact, we don't want it to be there. And if we remove that resistor, that means that our input to our little special board is through here. And this actually poses an issue, is that I don't have a place to put that big of a resistor on here, especially with all the other electronics. So it looks like once again, I can't use these little boards. Too bad, because they're clever. I'll have to make my own little circuit board. So let me put these away, and then we'll get out. You know, all the effort for all these little boards, and they're always useless. Useless! They like barely come in handy. Stupid things. If I had a couple of those, that would work out nicely. I should order a couple of these things. These ones that have like all the structure to them. Because then I could actually create a little daughter circuit that would go on to the rest of this thing. It'd be like two inputs and then the resistor across them, and then oh well. Ah well. Trying to keep it simple here, but it never works out. I could also just build the whole circuit elsewhere. Well, okay, so if we come in, we're coming in on this pin, so I just need that pin to go to the rest of the circuit, and then maybe I can put like a DuPont header on that, and then the shunt resistor, where is that in relation to the rest of the stuff? I guess there's a lot of additional electronics on there, so I can't really utilize that shunt. Oh, I guess I could have put this to ground. I could have put the 2K resistor in its place. Yeah, we didn't do it because it was easy. We did it because we thought it would be easy. That's pretty much this whole show. That's pretty much this whole stream is that. Yeah, I suppose I didn't need to sever that trace. I probably could have kept it and then put a 2 kilo ohm resistor there. But I guess this way we have a plug that just has the one thing. It's like I did this. So now we have R and B, but we only need one of the wires. So I could put a one pin DuPont connector there, or just keep the 2-pin connector. But this is fully isolated to this trace. The only input that we need is power to come in. We don't need negative because we'll get negative reference through ground, and our power's going. The load is going through there, so we don't need a. We would basically need a wire that goes out to the load. Or would it go to the load source and then the load? It would go to the load source and then the load. So actually, this is okay if we sever this, and then I have, but I don't really want load source. We already have 3 volts internal. We're gonna make that regulator help power us as well. What is air but nature's over 2 RK resistor? What? What does that mean? 2 RK? Yeah, we're not air wires. No, I get what you mean. I'm just thinking, I'm thinking about what this is gonna look like. Because if I have I can either have the circuitry on this device, or I can have it on the PCB that's going to be with the module tester module. It can be on the power supply. So it can either sit on the power supply and then I have more room to work, or I could have it as a little thing that I have on the back of each of these meters. But it's going to need to maybe be tuned unless our equations are perfect. I can't believe that it was just the matter of making those 2 resistors the same value. Two resistors out to the load, or 2 wires out to the load, and then I would have to break the connection from there. That's already connected all the way to the microcontroller, which is kind of crazy, only through a 10K ohm resistor. So I guess what I can do, I'll have these separate. But then where do I get power from? Damn it. Hold on a second. I'm not going to have a 3-volt regulator on the power supply. The 3 volts would be made locally for whatever microcontroller. Oh yeah, I guess I am going to have 3 volts because I'm using a Teensy. I need something that's going to make a lot of 3 volts. I think I still have a Pololu power supply that'll make enough of 3 volts for me to utilize. So maybe I do that. So all the circuitry for this will be on the power supply board. So it's PSU board, and then there's 1 connection additional. And let's see, this resistor would be gone. And this is 0.018. Okay, so we have an idea of what I want to build. I don't really think we're going to be able to accomplish it within an hour. And I don't want to drag the stream out because I'm tired. I've done 3 streams in a row. I have been on for 3:30. God damn it. I haven't been on for very long. We came to our conclusions pretty quickly and brutally. We've done a very good stream, and I thank you guys very much for helping me work out the answers to a lot of these problems. But we have an idea, we have a plan. I just need to build it and test it. So I need somewhere that I'm going to be able to put this together. Maybe we'll put it together on the breadboard, and then we can test it on the circuit itself. How hard would that be? Well, I've got most of it built on the breadboard already, except I have to find the different op amp, the 3-volt op amp, and I'll need to set it up with the 3-volt power supply as well. We can tear into that a little bit right now. Yeah, let's do that. Let's do that. I'm feeling a little dehydrated. I'm feeling a little tired, but we can get this up and running. We can get this up and running. Let's steal the 0.18 resistor and get that onto something that we'll be able to use it with, and then we'll put it together with our, I guess we'll do the 12 volts. So let's unhook all this stuff. Unhook all this stuff, including our big shunt resistor. We'll be using that later. We don't need the matched 200Ks. Move that power off there a little bit. And we're not doing plus minus 12. We need to get it down to 3 volts. So let me get the minus 12 out of here. This will actually use the regular low side ammeter, because it just can. It can do that because it's the low side. It's isolated. Nothing else is. So annoying. All right, this goes back in the bin. Let me get my perforated prototyping. Well, let me get all my chips over here. Okay. And what are we looking for? We're looking for the OPA part number. Those are over here. Oh, I'm running out of them. Jeez. Well, that's okay. We can get one of these. We can use one of these. And then we need to get our 0.018 resistor off of here. Could we have preserved that? No, I don't think we could have. It needs to go. It has to go. We have to see. We have to know. It was a jungle song. Breakbeat. Future Engineers? No, that wasn't Future Engineers. Oh, maybe it was. Or Future Class DNB. Something with future in the name. Get some power on this, and what I want to do in order to remove this is just get both sides hot enough that they've got molten solder on them. This is not a very large value resistor, so I think there's going to be a lot of bleed in the heat from one end to the other. To be fair, I didn't have to sever that trace. That didn't have to happen. I didn't need to do that. We sometimes go at such a pace that I don't realize that I don't have to do certain things. But this is such a low value, I think we're going to get a lot of heat running across there. But let's refresh the solder with a little bit of new solder. And that gets it more towards the alloy that I'm using. Go. And now, if I can bounce bounce on these pins enough. Yeah, see, it's just, everything just remains hot. There's just so much volume of metal there. Oh, don't want to burn out my resistor. Go. All right, so now that pin is basically going into the little 10K filter with a 10K current limiting resistor. So that's it. That's now a digital input. Well, it's an analog input, but it's 0 to 3v3. Wait, did that soldered itself back down? Damn it. Don't you tombstone. Oh my god. There we go. Stupid thing. Play us out. What does that even mean? Ow, that's still hot. All right, there we go. So there's our 0.18 ohm resistor. Strange value, but I guess it's calibrated to what we need. How am I going to get this onto the prototyping board? Maybe this is where those circuits come in handy. The little boards come in handy. Do. I can't believe some of my chats broke. Everything is falling apart on the production side of things today. That didn't burn out the resistor. What would? Well, so the resistors are usually pretty good at taking heat. But, you know, having it sit against a hot soldering iron for too long could, in the past, damage stuff. Heat higher than what I'm using is probably what might burn out the resistor. But it takes a lot. I mean, it's not easy. It takes a lot to make a stew. I don't think I want this one. I mean, I could just make something, like a little board that had the contacts on it. Or I could just use this temporarily. Yeah, we'll just use this temporarily. We'll use this one. How much time did you invest in Paint Mastery? It just over time. It just happens over time. I like a good simple program. Mouse make lines, simple as. All right, so our shunt resistor is going to be going across this massive contact. I mean, when I use the shape tools, it comes out even better. Shapes and line tools help clean things up, but it's like, I don't know, I'm taking quick notes, so I don't need fancy things like non-wavy lines. Whips out MS Paint. I'm something of an artist myself. Oh, you do art? Boots up MS Paint. So do I. All right, there's our shunt resistor. We just need pins on this thing, on this little beast. Let's get this pin over here. Get pins out of this. Pins. We need 3 pins for this thing. 3 pins. Check. And the pins go into the board to dissipate the heat. And then to do these vertical boards, I guess I'm just going to like hold it up. Make sure it's straight up and down. Do an anchor pin. This thing is far too tall for this purpose. You know, this is for voltage regulators, and maybe one day I'll want to do something with a voltage regulator, but today is not that day, and I think I'm going to cut it, because you can get more of these things for $1. Cromch. There you go. That's just a little bit more wieldable. I haven't used that board in, like, how many years of my owning it, so there's no point in preserving it. It's going to be crooked no matter what, isn't it? See if I can get it to not be crooked. You guys get a little further up. That's better. I don't want my you guys get like crotch view of everything I'm doing. Little goblins. Ah! Close. All right, that'll probably do. That doesn't help. That doesn't help me solder. Maybe we'll just do it without heat relief. There you go. Okay, there's our shunt resistor. Doesn't need 3 pins, but it's got it. So our 0.18 shunt resistor is the first component in the rest of this. our load resistor here is designed to give us a sort of average kind of modular synthesizer load. Let me get this pin off of it. It's about 300 milliamps. Let's just put the, you know what, I can't stand this thing. I need to make it properly. I can't stand it. We'll just quickly put this together. Move you guys a little bit here. Just get you into the right spots. We're making this a little bit more organized. It's going to be a little bit nicer. I still love that I broke Robots today. By posting a picture of my corgi. You can't stand it. It's totally revolting. Chonky Boys, yeah, it's good to have resistors like this in the shop because they help you test the loads. Not what it sounds like. I'll keep a little space in between them so that they can cool off. These things tend to get quite spicy when you work with them. This reminds me of Uo's lab making the big capacitor banks in his shop, in his lab. I don't have access to that many giant capacitors, but that would be a fun thing to do. But he was getting them together so fast, it was insane. I just don't operate at those speeds. Oops, I put it too close together. Hold on, let's space them out a little bit. There we go. Yeah, there's just a little bit of room for air. This is even shorter. I have to keep looking. I'm like a freaking groundhog looking up all the time because I'm looking at chat and stuff, trying to see there's no movement at all. Everybody's like enjoying this beautiful Friday around here, at least. I don't know about the weather with you guys, but for us it's like gorgeous. Absolutely gorgeous. There's like no humidity and everything. Turns out I've got like a huge cough. I've got like respiratory distress just because of how nice it is. And so it's so unhumid that my body's like, oh wait, we're full of bullshit. I'm like, well, what do you mean? Stop it. Cool. Look at that. Beautiful. This is much better than what I cobbled together before. As far as loads go, this one is impressive. Wait, what am I saying? What did he just say? Why did he say it like that? Maybe I should bend this to the side and have it come out at a right angle. Try that. Is you building a coffee warmer? Essentially, in the end, it is. That's gonna hurt if I push my finger against that. Yeah, this thing is designed to get kind of toasty. That's why it's all spread out. How about this? I joined mid-product. Can you review what the product is? No. The project, we're getting towards the part where I breadboard this. But if you want to know what it is, I can explain it quickly. We're basically making a low side voltage sensor, a low side ammeter into a high side ammeter using an op-amp circuit. And we've done a little bit of reverse engineering in order to figure out how the ammeter works. And now we're putting it all our knowledge down onto the board. Well, that came out to be a very smart little load resistor. Look at that little guy. There's a 300 milliamp at 12 volts. Pretty cool. Pretty cool. I even impressed myself. Okay, so this is an op-amp. It's an MCP 6002. The 2 at the end of the part number designates how many op-amps are in here. So inside this little thing, inside this trench coat, there are 2 op-amps. The MCP 6002 is a low power op-amp. So if your op-amping needs are low power DC, then this is the way to go. It's a pretty good one. It sounds pretty nice. It's got good capabilities to go into a microcontroller from modular synthesizer stuff. So the MCP 6002 needs 3.3 volts. It could run at 5, but it needs 3.3 volts in order to function, and that's on this pin. And then on this pin we have ground. Ground is going to be shared. We have still remaining a 12 volt voltage regulator. The Reg 24G goes up to, I believe, 50 volts, and it creates a shitload of whatever power it's configured for. This one, in this case, is 12 volts. So this 12 volts is coming out nowhere. So I'm just going to put it to the positive voltage rail. Let's get that 12 volts, and let's get that all the way over to the plus sign over here. I'm going to retain 12 volts of the plus sign and ground on the minus, just to get a little bit of standardization here, so we're not confused. Now, that said, 12 volts does not make the MCP 6002 work. I need a slightly longer lead. Where are my things that I cleaned up earlier? Always down to that, isn't it? So as you clean this up, how dare you? Now nothing is where you thought it was. What did I do with the little kit of wires? What did I do with it? Where did it go? I'm looking around. I'm looking around. I'm not seeing it. Where'd I toss that thing? It's like just a little package of wires. It would have been within the radius right here, because I know I didn't move far today. I only moved farts. Fascinating. This thing is just gone. Where are my yumpers? I had the kit over here, and then I put a bunch of wires into it, and then I did a backflip, and maybe somewhere in there I lost it. Or I moved it to a non sequitur location, and I will never see it again because it's in a weird spot. That happens a lot. More than you know. I mean, I've got my other wire kits sitting over here, so we're not totally out of it. It's just a little concerning to me that I would lose something like that so easily. This cough is really bugging me. It's like every time I finish saying something, my body wants me to start convulsing. Oh, wait, is it under this? No. No, it's not. No, it is not. No, it is not. That would be easy, and nothing is easy around here. Nothing at all. Nothing. I could have sworn it would have been in a stack with a bunch of other stuff that I was using a minute ago. Oh, there it is. It fell to the bottom of this case. Ta-da! The perils of organization. To be clean and neat is to not know where any of your stuff is. Chat is supposed to be appearing on screen. You guys wouldn't know it, but chat's just going. It's like at this scroll. Just this constant scroll of people talking, and you can't make, heads or tails of it. I'm missing like entire side conversations that are going on just because chat is just so active right now. This is Kuro Kesu, and I'm not sure I think they still exist. They were in a pretty tumultuous location for a little while, but they make these aluminum enclosures for Logitech webcams. So this turns a Logitech webcam into a C-mount device camera. And so I have a C-mount to Nikon lens adapter and then a Nikon DSLR lens. And so what that does is that gives me these beautiful microscope images with about 2 feet of standoff to fit all my shit under. It's pretty nice. It gives me these beautiful 1080p webcam views of stuff. All right, so. Oh yeah, I don't really have 10Ks, do I? We're gonna have to figure that one out. This is the 3904, and then this is the 2K here that we did yesterday. I forget what value this one is. I'm just taking it out. I think that's the 200 that we're not gonna need. We're only using 2 kilo ohm things on this. These are 100, no, these are 1 ohm resistors. Those are dangerous. And this is our 0.018 ohm resistor. That's our shunt. So this would go from one end of our new resistor pack to the other. And then that would go to ground. Excuse me. Okay, so let's see. Don't need to solder. Don't need the solder. We need the yumpers. We need the wire cutters. Get all this shit out of the way. And we won't connect it to this yet. We'll start without that because I don't want to blow it up. There's always a chance something is wired just a little bit wrong and then we blow up our stuff. So, okay. 3 volts. 3 volts will be achieved through a regulator. And for that, somewhere I have an LM1117. That would be this one. We got to make sure that this one is a 3.3 flavored LM1117. These LM1117s can take your 12 volts in, and they'll give you about an amp of 3 volts, which is probably all the 3 volts you're going to need unless you're doing something incredible. AMS 1117 3.3V. Okay, cool. And then we've got it labeled over here, V in, V out, and okay. Giant dry sausage fingers. Yeah, 1 ohm resistor, they're 1% 1 ohms, and we put 2 of them next to each other to make a half an ohm resistor. But then included with the ammeter is this 0.018 ohm resistor. That's what we're going to use, 0.018. So 0.018. And mathematically, we did a little bit of math, although I did it by dead reckoning instead of actual equation rearranging, because I always second guess myself when I start rearranging equations. We just figured out that if R2 is equal to R1, according to this equation right here, that if we have if we have the current of 150 amps running through this, the voltage level matches this equation when we have the 2K resistors as R1 and R2. There's a little bit of mathing it out right there. What's up, Baloo? How you doing? How's it hanging? So, okay, for those that don't know what's going on here, this document is my working document for the module testing module. I am building a modular synthesizer tester so that I can get a bunch of other projects done. We are in the fractal stages of yak shaving. Yak shaving is when, in order to perform a task, you have to perform a lesser task, and then a lesser task, and a lesser task, and those tasks are all projects in and of themselves. That's called yak shaving, and there's the Malcolm in the Middle joke that you can find the gif of, where the dad, in order to fix the shelf, he has to fix the light bulb, he has to fix the car, in order to get parts for the, yeah, that kind of thing. That's what's going on in this project, but we're learning a lot of stuff, and it's been a good little process. It's gotten us through a lot. Hey, what's up, Groovy? How you doing? So I'm trying to get together what the whole thing is for this board, and in order to run a modular synthesizer tester, I want to be able to see what the voltage and the amps consumption is of the thing that I've plugged in, just in case I'm arc welding something. So what I've done, yeah, that's what this, wait, 1.99%. I could change the description of my job to yak shaver. We're so many tiers down that it's getting hard to remember what we were working on. It's gotten to that point. So we've been bumping around the bumpers of this bumper pull session trying to get this thing to function properly. It turns out most of the stuff on Amazon are low side current detectors, and I can't search whether or not they're high side or low side. Because our modular synthesizer has 3 power rails, that ground rail, plus and minus 12, that ground rail is shared everywhere. And the low side current detectors rely on isolated grounds. So we can't do the current measurement that we want. In fact, it looks like this. This is what we even almost tried, but we forgot that inside of all these power modules, ground is just connected back and forth. So things just kind of go 2 ways here. Circuit node wise, this would be just as if I'm measuring the same thing. I would be measuring nothing because there's a continuous loop from one side to the other side. So that's pointless. So what I've done is done a little bit of hunting and a little bit of searching around, and I found a current mirror circuit. So current mirror circuits mean that we can output a voltage depending on what current runs through our sensing resistor. We compare the voltages on both sides of the resistor, and then that induces a current on the other side of the induces a voltage on the other side of the op amp. V equals IR and all that stuff. So what we did is we used math to figure out what was there already. It's got a 0.018 ohm resistor, and so if we use a 0.018 ohm resistor in this circuit, we were able to tune the maximum output of 150 amps to whatever the resistor values are that make this thing work. It's a big thing. It's a big process, but we reverse engineered the actual ammeter. This is how it works. It's got a microcontroller that has probably some pretty robust analog inputs. I think it can measure some pretty high voltages, to be honest, because it seemed like at a certain amperage, yeah, 10 volts you get, or sorry, at 100 volts input, which it says it can take, you get 10 volts into this microcontroller. So I think those analog inputs are specialty. They must be able to take quite a bit. Because a 3.3 volt device, that's what we're giving it from the voltage regulator, which we also reverse engineered, and that was a very interesting little piece of the project. So now we're breadboarding this circuit and hopefully getting the values correct, and maybe we can get this thing to read amps in a sensible way. We have our 300 milliamp load at 12 volts, which is 4 7-ohm resistors of high current connected together. And now we're getting 3 volts into our op amp. Ooh, God, it's a lot of talking when I do this stuff. So in, ground, out. In, grown, toenail. In, ground, out, I mean. I guess if I put it all the way over here, I can get to the front and the back, because Artful Dodger told me that that's where it was at. In, ground, out. So this one's out. That doesn't have to go very far, so I need a much shorter jumper on that. And then I'll use tweezers to make a nice right angle bend on this. It barely reaches. I guess I gotta move over one. There we go. Move over. Is that northeastern accent? Positive. So in, ground, out. Ground, ground, and in. Both right here. So now we need to make those jumps. Where are those? Well, we tore them off of the desk and everything, so I got a couple of them in here. So this one would be ground, and that needs to be the longer one, so this will be yellow right there. This prototyping board has seen some strife in its day, so some of these holes are not cooperative. You can see there's just a little folded piece of metal inside, and it's a folded piece of metal with 5 locations on it. Although, man, we could use some editing of this type of a board. I would like to see more of a variety of these types, because sometimes it gets real hard working in these conditions. Working in the mines. ground to here. So long boy. I don't have any green boys. There's a green boy. It's a green boy. Didn't Rabaz raid me one time when I was doing this kind of stuff? Or maybe he was going to and Twitch broke or some shit. But we were working on something that was so complicated that it was just like scaring everybody off. That's one problem with my stream. I'm not, you know, I don't do like, oh, this is the game where we click on stuff and it explodes. Like, I don't do that. Okay, so the op amp is over on this side. Let's look up a pinout for this thing. It's 2 op amps, but still. You designed a tuned mirror circuit to sense the high side that outputs the voltage for the voltage regulator you bought to end up with the high side voltage reader. Close. We tuned a high side current sensing circuit to output the same voltage as the low side current sensing circuit using the same shunt resistor. Did you get it to run Doom yet? Yes, it doomed me. So we're using this circuit to fake being this very much simpler circuit. We're faking being the other circuit. There was just a lot of reverse engineering between here and there. What was I doing? I was looking at the pinout of the MCP 6002. MCP 6002 data chart. Bonk. Was that any activity that I missed? Did I miss anything? I saw Syphilid 8. I saw Science Streams rating. Okay. We're up, we're up, we're up. Rap. So VDD, Vout B, VNB minus, VNB plus. So it's out minus plus. And I hook it up like this. So minus goes to load. Out minus to load and the shunt. And if I put the shunt here, then I'm going to need this pin to that pin. And then the load goes to ground. Plus goes to all the way over here. Is there any way that I could swing that? Maybe we'll do that on this side, because it's minus and plus are right there. And I'll put the shunt here. Well, actually, it should be probably over as far as I can get it. Because then we connect all of these pins. I guess I need 2 of the same jumper that are a short distance. I guess, is that going to make it over everything? Yeah, okay. So this one, well, I could do it like this, like that. There we go. There's a shunt hooked up. We're just kind of reversing it a little bit. And at the top of the shunt resistor on the positive input, so, oh wait, well, the shunt, oh, it doesn't directly connect. Wait a second. So I could do it like this, and that gets me connected on minus, and then I need a 200 ohm resistor from here to here. Okay, so 200 ohms. We've got a couple of those on the field. Let me see if I can find one kicking about, minding its own business. Faking making things faking making things look easy by doing it in a way more complicated way. That is a difficult one for me to wrap my head around. It is kind of what we do. Today has been kind of a good day because things have been happening properly. The past 2 streams have been a little frustrating for me. 221 is close enough. We're faking making it look easy because we're extremely good at what we do is more like it. That's because we've been around the block. I didn't stream until I'd been in industry for 10 years. I had a little bit of experience under my belt to bring to the table. All right, so that's that length. Oh, so it's pretty much just the length of the resistor, huh? Bend those down. Oh wait, this isn't supposed to be this isn't 200. This should be 2K. Get this out of here. It's in the bio. I used to reverse engineer IEDs. We've gone pretty crazy into the reverse engineering before. We faked being a Bluetooth module that connects to a wireless wheel module by coding in all of the Bluetooth low energy instructions and timing out the handshake. So we were able to make our device handshake with a device that thought that it had a Bluetooth modem plugged in that then went and connected to a wireless steering wheel module. There's not a lot in the bio. I pretty much told you everything. I guess we're going to have to make a 2K out of two 1Ks. We did that before. I don't know why I don't have any 2 kilo ohm resistors, but I guess I just don't. Oh, Madam U, did you say something recently? Sorry. Sorry, bud. 400-mile road trip. I don't know what that comment was for, and it could have been years ago. I don't get timestamps for the YouTubers. Chat's been very quiet today. It's just one of those days. Oh, this tool's unfortunately too expensive for what it is. I would suggest going on like Thingiverse and looking for something, or maybe you can find something online that's similar to this, but this is a Fluke, or no, Pace. Pace makes this, the Pace Comform. Pace Comform 1. It's way too expensive for what it is. It is very useful, but like, you know, one of the little pointy bits snapped off on mine. So we need two 1Ks that are going to make up a 2K. These will be put in super duper compact resistor mode. Just bend that down. Give it a cut. Yeah, I think it's because they have the patent on it. I'm not sure if I've gotten $40 of use out of this. I would almost say like I have. I would almost say that I have. You know, $40 is what, like McDonald's nowadays? Why does that not feel right? Oh, because there's a wire in here. There's a wire stuck in it. I need to be able to see what I'm doing. So we're going to jump there with our first 1K. I hate these resistors so much. These small leaded resistors. They're so hard to work with. And they're all you can find to buy. They're it. That's it. That's all you can find. You know, maybe I do need to talk to somebody at, like, you know, give DigiKey a phone call and talk with the representative and go, I need resistors that have normal sized legs that are 1%, and they come in a giant pack of 1 billion. It's just, these are so easy to find. Yeah, I mean, quarter watts are so big. I revulse at that. All right, so there's our 2K. I'm going to need a longer lead on the ears itching. Okay, I'm going to need a longer lead on this one. Need a green wire here, which I don't know where all the green wires went. I don't know why I'm missing all of them. I thought I got them off of the table. I don't think I threw any out. I organized. I cleaned up. I finally had time. I don't have any in this kit. I'm shocked. I'm shocked. Where have all the resistors gone? I basically need to get to here. That's a much longer than green. Maybe a blue. I've been doing a lot of analog stuff, and it's kind of peace of mind having 1% resistors. Because then you don't have to deal with the poor. That was a 1%er joke. That was, you know, you guys get that? Did you get it? Okay, so that goes there, and then our shunt goes here. Shunt! And then one of our shunt leads goes to the load. And the other one goes to power. So that would be, this one here goes to, well, wait, this is minus. So minus goes to the load. Oh yeah, that's what we're doing. That's what we've got configured. So this one goes to power. So this goes to plus 12, which I'm putting all the way over here. So that has to go all the way to here. How am I going to route that? Minus plus. Plus gets the resistor. Oh no, minus goes direct. Oh yeah, that is minus. Plus gets that, and then on the other side of the 2K, hold on, I'm getting confused about this. 2K goes to the shunt, then the op amp, and then this goes to the transistor output. So this right here is the positive path. So this pin right here, I need to go all the way over to there. Okay. So, oh man, and of course it's in a blank space. Why are these there? Why do these exist? These are so stupid. These suck ass. They're so bad. Put a pin there. What is everybody's problem? This is a relic. This is a dinosaur left over from when only the 5 at a time would be connected. And then some of these boards in the middle, there's a split on the power rails. So you need to be careful. You need to actually like make sure that you don't have one of those. 10% and having to read a bunch to get a match pair. That is terrible. That sounds awful. Nobody wants that. Nobody. Nobody. I never had to deal with plus 10%. And I've seen some old electronics. I've worked with some old stuff in my day. That one barely reaches. Is orange longer than red? I think after red is that awkward size that where nothing fits. So I guess we'll have to just live with that. We'll have to live with that stretch. So then that goes through the load, and then we've got the shunt resistor across, and then that's the minus pin goes to the load. Plus node with the shunt resistor also has power, and it goes to the plus, wait a minute. Plus pin goes to those two locations, and then on the opposite end it has power. Power also shares with the shunt. Yes, okay. So there's that plus node, and now that goes to the collector of the 3904. If you've ever worked with resistors, you know the pain of working with, or sorry, if you ever worked with transistors, you know the pain of collector, emitter, etc. And the data sheets, and the old data sheets that gave you a picture of it gave you a picture of the letter D, and it labeled 3 pins, and you don't know if you're looking up from below or down from above. Hand wire wrapped base VGA card back in the day. 5% was the most affordable way to do an R2R. Damn, that is way back in the day. So this is an LM3904. We can find out the pinout because we probably opened up the datasheet yesterday. I'm so tired, boss. We've been working on this stuff quite heavily. I want to get the circuit done, though, so we can see it. Oh, another beard hair. I shouldn't pinch my hair when I'm thinking. I had a goatee in college, and I made a huge bald spot under my chin by getting too worried ahead of an exam. I kept plucking hair, just not thinking. Okay, so 3904 datasheet. 3904 datasheet. Did the same thing. It was terrible. 3904, 40 volts VDC. This is one of those jelly bean parts that everybody uses in everything. They're good at switching. They've got pretty good biasing capabilities. You can use them as amplifiers. They are neat little devices. However, they're a little bit old, but getting that pin out, you need to have like a 3D picture of the damn thing. They always confuse you by just showing you like the shape. You'll get a drawing like this and have the 3 pins labeled, or have just like the number 1 next to a pin, and you're like, what does that mean? So all of the manufacturers eventually started giving you a little 3-dimensional layout. And I love how they don't give you gate, drain, source, or whatever it is, base, collector, emitter. They have 1, 2, 3. 1, 2, 3. Okay, where's the key? What is 1, 2, 3? Are you serious? There's our key, all the way up here. Little hobby component testers. I got one, and yeah, it is actually really nice. It's really nice because these data sheets are terrible. So anyway, 1 is the emitter, center pin is the base, and 3 is the collector. So we need to set up the collector on the node of the thing that I was just looking at. So the collector being a much cooler sci-fi term than it is a transistor term, but the collector goes here, but I don't have anywhere to work. And then the emitter goes to our output stuff. And the base goes to that thing. Okay, so if I can do collector to the other end of our 1K, and then basically what I'm going to do is put the emitter out beyond that positive terminal. So pin 1, so I want, okay, so I want this pin to be way out there, and then these 2 can go right here. So 1, 2, and this one I want to be just beyond power. It's right there. Just like that. There we go. Good. Double check my work. Pin 3 is the collector. The collector goes to the junction of... That's wrong. Okay, yep, that one needs to be 1 further down. Because that shares the positive, and it goes output minus plus for the op amp. So I need it like this. My hand hurts. Hold on, I need tweezers to help me with this thing. Maybe I can get it. There are better ways to bend these terminals so that they go in properly. Oh, why did it do that? Fine, I'll keep it this way. It doesn't matter. As long as it's making a connection. Okay, cool. So then this is the output from that thing, and that goes to a 2K resistor, or 2 1Ks in our case. And that's the ground. So I can just do this, and then I can split this up a little bit. I can open this one up, and we can bridge the gap. I could do that with a flat resistor, but this is already configured this way. Okay, that's a 2K resistor to ground. So now at this point, we will get a voltage here that represents the current that's going through the rest of this thing. So what is that gonna be? What is that gonna be? What is that current gonna be? Since we have 3 7 ohms, so 28 ohms. So it's 28 over 0. No, that's the voltage. Hold on. V equals IR. So V over, or sorry, it's, oh, just I times R. So 28 times 0.018. But this was divided by. But then we were calculating for the voltage. Yeah, so we're trying to find out what our voltage is going to be. So it's going to be 28, clear. 2 8 ohms times 0.018. So it's going to be 0.504 volts. That's what we're expecting to see. So I'm going to slap this thing with 15 volts. Oh, I still need to hook up power and ground to the other side of the board. Power und ground. 12 volts going to this trace here. And then I need ground to ground, so I just need a long wire. Just a long, lumpy wire. That's ground. So we have ground, we have power, we have our shunt, we have everything else hooked up. This op amp could probably use one of these from output to minus, just to make it unity gain. I'll be up here. That just stabilizes the op amp. I probably need to ground the plus, but I don't know if I have a wire that'll do that. I'll do this. There. That'll stabilize the op amp and just keep that thing from running away. Okay, so everything is stable. Everything's ready to go. I have 15 volts over here that I can plug into the circuit. Get this out of here. That's not getting out of here. This is too close. There you go. Move that back. Okay. All right. So minus to minus. Ashes to ashes. And then what do we sense voltage with? My multimeter is not that accurate. Let me boot up the scope and put that up on screen. It makes my stream look more impressive. We're not working on scope complicated stuff, but we might as well just get it up on screen because it looks cool and it makes me feel awesome. I tried your toothpaste and it made me feel like a piece of shit. Oh, I don't have deployable legs. That's right. Those are back here. Legs for days. All right, let's get this thing out. I need a more organized scope setup. We are turning a current sensing, a low side current sensing ammeter into a high side current sensing ammeter. And so we've done quite a bit of math and quite a bit of circuit theory to get us to where we are right now, and we are just getting to the test. So according to our theory, we should see 0.5 volt. And I'm booting up the scope so that you guys can be front seat to all this stuff. Scope takes a full damn minute to boot. All right, so let's put the scope on. The eventual result of what we're doing is going to mean that I'm able to measure the current going to a modular synthesizer module that's under test. So I'll be able to see whether or not it has shorts and stuff in it. But in order to accomplish that with the cheap ammeters from Amazon, I have to fully reverse engineer one and then figure out what the voltage specs are and do a little bit of theory crafting here to put this all together. So I've got a 12 volt power supply. I've got a 3 volt power supply. I have an op amp that's set up in a current mirror configuration that should get us 0.5 volt on the voltage output line from this circuit. Mathematically, that's what worked out. Let's see whether or not that's what we get out of this circuit. All right, ready? Here we go. There's not enough people here for me to do like a what do you call it? A prediction or anything. Nobody's like awake. Oh no, there's a couple people here, but it's not as busy as things can normally get. All right, so 3, 2, 1 power, go. Okay, don't see anything. We're not drawing any current though. Minus is on minus. Oh, this isn't plus. All right, here's my 15 volts. In 3, 2, 1, go. Oh, go. 0.2 amp. Nobody's getting warm. Are we producing power? Well, we've got, currently I'm on quite a few volts here. We should be up at 500 millivolts, and we're not. So let's check our power. Oh yeah, that's going to be off screen. Ah! What in the hell menu did I just pull up? Jeez. I like poked it with my nail and suddenly all my IP information is up on screen. We're not getting 3 volts. In-out ground. Ah, I see. Okay. Power off, power off. We wired up the regulator wrong. It's in-out ground. Get a larger. All right, in-out ground. 3, 2, 1, go. Nobody's heating up. Well, our voltage regulator is getting warmer. What does the scope look like? Not 500 millivolts. All right, let's, oh, but it's not hooked up. So right here, nope. Is our shunt heating up? None of this stuff is heating up. I wonder what's going on there. Let's see, positive 12 over here going through there. Do we have 3v3 here? We don't. Ground to ground. This one at 12? Not at 12. Oh, wrong connection. There we go. Okay, LED on. Everybody's running. So now we check here. That should be 500 millivolts. Zoom in. It's not. It's not at 500. Even just connecting this is enough to disturb the circuit. Okay, so what's over here? What's over here? It's over here. Ground, ground. Why is it so lumpy? What about you? You're 12 volts? Yep, good 12 volts. Can always rely on these Pololu regulators to do things properly. How about you? 3 volts? Yep. You are at 3 volts. How's our load resistor doing? It doesn't appear to be, it should be warmer than that if it's actually doing its job. We're going through the shunt resistor. Oh, it's connected to minus, not plus. Let's just double check that that's correct. Yeah, this is on. Okay, so let's put a load through it now. And let's see that voltage spike up on the output. It didn't do anything. Of course, I'm having trouble plugging it in. Okay, now we should be going through our shunt. There we go. Our shunt's starting to heat up a little bit. So that's 12 volts going through there, going through the shunt resistor. We've got all of our stuff hooked up, and then we look at the voltage here, and there's nothing. Oh no, actually, we're looking here. That should be 500 millivolts, damn it. No, it's here that it should be. This should be 500 millivolts. Wiggle, wiggle. Wiggle, wiggle. Nothing. All right, there were so many mistakes. I got to double check everything. There to there, and then we got the 2 there that do the 1K, 250 going over to the collector. The base is on the output, not the wrong pin, no. Yeah, everything's correct. Everything's correct. All of my equations were correct. Where have I gone wrong? Everything was right. We knew the solutions. How could we have predicted such an outcome? Was it our hubris? Is God laughing in our face? Oh. Anyway, sometimes things just go wrong with this stuff. Sometimes things just don't fucking work. It's very, very frustrating out here, let me tell you. What we should be seeing right now is in reference to ground, we should be seeing about 500 millivolts, 504 to be exact, according to our equations. But this circuit is copied directly. I mean, this is a, whose data sheet is this? Who told me to do this? You bastards. I'm going to find you. Where is this? This would be Analog Devices. I trust Analog Devices. They seem to know their stuff. And so our circuit is this, and I'm testing at that 2K, but it appears as if nothing's happening. And we should be seeing the equivalent of a couple hundred millivolts. I'm going to turn this off before things get too hot. We are drawing from the power supply at 12 volts. We're drawing 300 millivolts, so we know that this shunt is doing its job. I should probably put it on top of the heatsink so it can dissipate a little bit of heat. It's a nice little shunt resistor, a nice little load tester that I've created. That's a nice load. Hey man, nice shot. What a good shot, man. Now that the smoke's gone and the air is all clear. I don't know. I don't know why this thing isn't working. There should be no reason why. This is a 3-volt op amp. It's measuring from the voltage difference from these inputs. Could it be that the op amp was deleted by the amount of voltage that it was seeing? If it is incapable of actually working with... What's so special about LT1637? It's possible that I need to get this part. One of Filter's best. They always play it in the stadiums. That's why I know, like, all the modern rock that I know, like, the back of my fucking hand. Oh, operates above V+. Okay, so I might have just ruined our op amp. I might have just blown up our op amp. LT, well, of course, it's the finest analog parts in the catalog you see. Well, yeah, go figure that the whiteboard description, or the white paper description of what the circuits we were looking at, happened to be specialty devices from this one company. So this is rugged. That word is thrown around with it's just no meaning at all. Op amp that operates on all single and split supplies with a total voltage of 2.7 to 44 volts. The LT1637 has a gain bandwidth product of 1.1 while blah, 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 blah. Unique input stage that operates and remains high impedance when above the positive supply. The inputs take 44 volts, both differential and blah, 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 blah. So we're going to need some LT restricted 1637s. Ending my week with blowing up an op amp, and not even in a fun way. This is the thing, like, we do stuff properly here, right? And if we do stuff, by the way, Groovy, I don't know if you watched all that Wheelie Yellow content, because I geeked out about Wheelie Yellow for a while. This is the truck that forms the basis. Well, it's probably not this one specifically, but there's a family of this sort of truck that makes up the Wheelie Yellow truck. I love it. I should get a bunch of balsa wood and just build a little RC van. It's just so much energy in the editing. I love it. No, we're looking for LT, what was it again? 1637. LT1637 delivers September 9th. Ugh. Sushi. Spare tire cover. Perfect. Oh man, I'm gonna have to source one of these things, huh? I don't want to do a DigiKey order of like 4 things. These are harder to find than you thought. I'm probably going to have to get it from DigiKey then. Let's try DigiKey. Well, buying one part I forgot on Mouser and paying $8 shipping. I'm kind of up against a a wall here. Because, yeah, those OPAs are not meant for dealing with this sort of thing. Although, can they? Wait a minute. MCP 6004, what is the input range? Because, like, they're using these with, like, 10 and 12 volts. Designed for general purpose application, 1 megahertz bandwidth. VDD, 300 millivolts, family of amps, designed. Microchips, blah, blah, blah. Available in industrial, blah, blah, blah. What are my input ratings? Input offset voltage? The temperature ranges. Because the op amp working with the HMIHOSDERGACIECEDSWTM. Why don't you just use the acronym in the future instead of having to say all that every time? Jeez. Just need 2 parts, so shipping is almost the most expensive thing. They have surcharges that they do now. They'll hit you with an extra charge if you're just doing 1 part. 1.8 to 6 volts. Well, shit. I think we're out of that range. I just got major deja vu. I don't know if we solved this problem in like a different context. Amplifiers. So this is the LT1637. In stock. We'll just do in stock. That's the only one I really need. I don't need bulk, but tubes and reels and stuff are generally what we're looking for. $7? Through-hole version is $6. It's an active part. Man, $6 a pop. And you know I have to buy like 4 or 5. The bulk quantity doesn't even get it down that below $2. Why is this thing made out of like myrrh? Like, why is this thing so expensive? Holy shit. Have just prices been out of check for this long? It's getting bad out here, guys. $7. Sort them by price. 16. All right, let's sort it by the other way. Sorted. Yeah, $6 for the through-hole version. I'd probably want the surface mount just in case I have to. Well, no, I probably want the through-hole version just because I'm going to build a little PCB around it. Are you using this for a current mirror? Yes, I am, Ben Gizmo. Ben Gizmo knows their stuff. They key into what I've been doing quite well. So my problem is that in order to build, let's start from the top and roll all the way down the hill. So lately I have been building modular synthesizer stuff, and I have all of these modules put together and no real good way to test them. In addition to that, I have been testing out Dave's M303, and anyone who knows anything about the M303 knows that it will definitely dip its balls into your glass of water. This thing hates you. It does not want you to have a functioning M303. And so we've gotten to the point where I've been reverse engineering this thing pretty low level. I used an INA 282. You can get it on a board for $5, and it does what you want. If I can get it fast, I'll do that in a second. But I'm trying to explain to you what's going on. So in order to reverse engineer this, I need something that gives it all of the signals that it takes in so that I can get it working again, right? And in order to do that, I need to build a module testing module. And so in order to do that, we learned a little bit more about I2S and how that works, and we were able to get it so that there are 6 independent outputs, and I can only have 2 independent inputs that can be switched to any of these channels. In order to make all of that happen, though, I need to start with a power supply, so I need to build a power supply. But if we're going to be putting modules under the knife, then we need to know how much current they're sucking down. And in order to do that on a modular synthesizer, you have plus 12 ground and minus 12. You don't have, and plus 5, and you don't have
individual grounds to your power supplies, not to mention the fact that the power supply modules that I have don't have independent grounds. So a low side current monitor can only be used on the -12 line. That leaves my +5 and my +12 up in the air. I tried to source a high side current monitor, couldn't find anything. So we reverse engineered the low side current monitor. It is a pleasant little simple circuit, and we were able to derive some formulas from that and figure out exactly how this thing was running and how to get it together. Then we found a white paper on the LT1637, a $6 part. If the boards that you have are $5, then I'm just going to get the right thing. Hey, what's up, Slime Swallower? Ugh, that's such a, God, some of the headier Twitch names. So anyway, we punch all of that data into here and find the appropriate parts and put it together. And I used an MCP 6004, and I probably blew it up. It probably blew up the circuit because the MCP 6004 can run up to 6 volts. And here we are exposing it to well over 6 volts. Especially here, we're exposing it to well over 6 volts. At least it's not GAC. If it was Floam, I would have to send you to the hospital. Oh, my butt hurts. I've been sitting for 4 hours. Almost 5 now. So we built up the whole circuit and put this thing together and plugged in the MCP 6002, and then it didn't work because we need what's called an over-the-top op-amp in order to tolerate the higher voltages. So that whole white paper was just to sell us their specific product. So let's take a look at this, the one that Ben Gizmo, not upload a list. Man, DigiKey has some powerful tools for getting your part lists together, don't they? I'm not paid by them. That sounds like something that they would pay me to say. If they paid me to say it, believe me, you would see. This just I would be smiling, but not with my eyes. So this is Ben Gizmo's solution to the problem, and it's a little bit cheaper. Current monitor, 8-pin SOIC. This is specifically a current monitor. How does it work? Datasheet. Datasheet. Okay. We're waiting on TI's server. Oh, I didn't get to cover up before that one. What the hell? What do we need? What do we need? Is this just like a shunt amplifier? Looks like it. This is too much. Listen, we've already got the circuit pretty much worked out. I'm just going to get that product. I'm going to buy the product from the other dudes and put it together and make it work for me. It turns a low side into a high side measure. Wait, it specifically does that? Hold on a second. I got to look at the datasheet again now. So the high side, and then it comes out of the output, but that's at a voltage level, right? Devices are voltage output current shunt monitors that can sense drops across shunts at a common mode voltage from -14 to +80. Independent of the supply voltage, the low offset of the zero drift architecture enables current sensing with a maximum drop across the shunt as little as low as 10 millivolts scale to scale. Current sense amplifiers operate from a single 2.7 to 18 volt power supply, drawing a maximum of 900 microamps of supply current. These devices are specified over extended. Blah, blah, blah. Okay, so 2.7 to 18, ground reference, output goes to output, 50 volt per volt. Bus supply, -14 to +80 over a shunt. How do I know what do what? You just use these for a similar purpose. Unsponsored. Sponsor. Set off the alarms. Okay, so the thing that I'm wondering about that device is we are trying to get to a specific voltage here. Basically at 3.3 volts, it's 183 amps. Or at 2.7 volts, that represents 150 amps. because we can't rescale what the microcontroller sees. The microcontroller sees a particular voltage level and it goes, that's this many amps, because it's the voltage drop across a 0.018 ohm resistor. And so we were able to duplicate that by doing a 2K resistor here and a 2K resistor here across the same 0.018 ohm resistor. Put a potential, a divider. I don't know. I feel like ours is more fleshed out and probably would work better if I can get the right op amp in here. So I'm just going to order the parts. You do it so it matches the scale of the IC. Let me check. I mean, this is pretty much the same circuit that we built. So probably with a couple little extra things in here. So this would be another option. I could use this if I really feel like I'm backed up against the wall and I need a chip to do that stuff. Supply bias, huh? All right, well, I'm not going to delve into this too far because, I mean, we've already got this. So I'm gonna order those parts, and I don't know when they'll get here. They'll be DigiKey part orders, and I'm going to get, you know, a slap across me bum because DigiKey doesn't like tiny orders. But I think that's it for today. Unfortunately, we could not have landed on our feet after going through that entire gymnastics routine. But we have hope for the future. The yak shaving continues. It gets delayed once we get this over-the-top amplifier part. So that will go in here. I'll be able to just plop it in, and then we'll give this a test, and hopefully this will produce the 500 millivolts that we're looking for over here. God, how annoying. How annoying. Here's the end card. I'll be back on Monday. Yeah, thank you for stopping by, Groovy, and all you guys out there, Madame Flaspin, Gizmo, Slime Swallower, you know, all these wonderful names that I got in here. That guy on chat. Who's the one that's talking a lot? Hi, I'm new. What are you doing? I know that was an old one. Line Squares, Ove the Duck. There's awesome people today. Yeah, we'll be back on Tuesday, and we'll get this done. We're gonna get this done. More delays. I hate this, but we're gonna get it done. I'm at my lowest right now. But just one more part, bro. Just one more part. One more part. Just one more part. And I don't know what broke my chats on screen, but apparently those broke. So 3 days, 18 hours, 59 minutes, 20 seconds. Be there or don't. I don't. You know, it's fine. But I will catch you guys then, and hopefully just one more part, and then I think we've solved the whole thing, bro. Just one more part. One more part. That's all I